one last thing is this. For all my guys, my website for Section 4 and Section 5 looks identical because I just basically import one from the other. But I do want you guys to continue. Don't let this be the only exam you guys do. Now, if you're in my class, I put down here at the bottom, I put down here old final exams from a while ago, and I try to be selective on these where they were very encompassing, where they had a little bit of everything on the exam. So these were very, very good exams. This is the spring 2011, fall 2011, and the spring 2012, and I did kind of clump them together there. But you have the exam and a video of me actually covering these things. Please go over. Don't let this be the only exam you guys see, and I'm going to talk about the reason for that. The other thing is this. Also, it is very important for you guys to go and do the course evaluation and let the administration know, obviously, lots of things, what you thought about the course in general. Now, granted, this is about the toughest of the calculus classes you can get is Calculus 2. Calculus 3 is actually better, easier than this. But it uses, the Calc 3 is actually a review of Calc 1, Calc 2 on a multidimensional plane, so 3 dimensions or whatever. But please go in and do the course evaluations. And please tell them what you think of the videos. Were they helpful or not helpful in terms of the class? Especially my class, who actually has the advantage in the sense that I record my class, so you get to see the class, and then you get to go home and see it again. The people that are in other people's classes, you just get to see it for the first time because you're in somebody else's classes, so they talk differently, but you can still see my videos and stuff like that. Please let the administration know what you think of these things, what you think of the web work, helpful or not. And remember, the engineering department is also big into web work, so we're trying to set you guys up for what they're going to do to you guys. And the course in general. So please go and fill out this evaluation. It's very, very important. All right. So let's go ahead and flip over here to this. All right. My job for today, and I do this every semester, where I go and take a copy of last semester's exam and actually do it for the following semester. So for you guys, I will be doing the fall 2014 exam. Now, at the end of this exam, I'm going to ask you guys a straight question. How well would you have done on this exam? And then I will tell you what the overall departmental university average was on this particular exam to see if you would have matched up or not. Now, obviously, when I get to do it for you guys, it makes it a little bit easier because I'm going to kind of signal and kind of be as straightforward as I possibly can in terms of why the answers are the answers and what I expect you to do. Now, when you're studying old final exams, this is the way you need to study them. Look, we've covered a lot of material in this class, a huge amount of material. And you need to look at these exams as a reminder of all the formulas you've done. I mean, because we've got so many of them, just to remind you of what the formula is and how to apply it. Arc length, center of mass, volume rotation, shell, disc washer method, spring problems, pumping problems. And also to let you guys know, 50% of this exam, guaranteed, 50% of this exam is going to quiz you, test you on your integration abilities. Basic rules you have memorized, the techniques of U substitution, integration by parts, partial fractions, formulas to plug into. And again, for those in my class, the way I did it in my test is how they're going to do it on the exam. They will give you the formula that's supposed to match up from the back of the book. We're not going to print you out the back of the book. We're going to give you the formula you need. But if you don't use this formula in just the right way from a U substitution perspective and keep up with the constants, you'll never get the right answer. Your constants will be off and all the answers look just like each other. So the way I did it on my test is how they're going to do it to you guys on the final exam. So, now, the exam is in 3 parts, just like it was last semester. Here's the only difference from what we did last semester when you guys were in Calc 1 to this semester. What time is your exam this year? 3 o'clock instead of 8 o'clock in the morning. What time do you got to be at the exam? And this doesn't matter, I don't care whose class you're in. What time do you guys need to be at the exam? Getting there, getting your seat. 2:30, right when the other exam finishes up. You need to be in there because it takes time to pass out the test, to pass out, and it's three parts of this test. There's a part 1, multiple choice, no calculator. You know they're going to hit you hard on integration on that one. Part 2, multiple choice with the calculator. And then part 3, free response. You, again, I don't care whose class you're in, you do not get to touch your calculator during the exam until everybody has finished up with that part 1 and your professor has given you the official word, okay, everybody's turned in part 1, you can now have your calculator for the rest of the exam for part 2 and part 3. Okay? But you'll look at this thing and go, just because I was finished with part 1, don't sit there and twiddle your thumbs and think, well, I'll just wait for the calculator thing. No, you can do most of part 2 and a big hunk of part 3 without a calculator. I mean, most of the thing is actually knowing formulas and applying these formulas. And you still got to show your work and use substitution, integration by parts, whatever the case may be, and all those application problems and stuff. So just keep on working on the exam, but if you get to a point where I need a calculator, we'll stop on that question, then go to the next question, start working on that guy, and then when the calculator is given the allotment, then everybody's got the allowed to use the calculator, you get to go back and just start plugging your numbers in the calculator, whatever. Don't forget to use your calculator to check your answers on those parts that you're allowed to have a calculator on. In my class, we went over that Riemann Sum Formula. Make sure you're well armed with that Riemann Sum Formula for Trapezoidal Rule, Simpson Rule, Midpoint Rule, left and right Riemann Sum. Because where most students will screw that stuff is, number 1, they'll screw it up by not remembering the formula, or number 2, by very badly putting it in on their calculator with a parenthesis in the wrong spot. You put that parenthesis in the wrong spot, you're going to kill yourself in terms of this exam because you won't get the right answer. Now, especially the free response part, we do grade off for partial credit. Okay? So if you at least write down the formula, write down you plugging numbers into the formula, you know you're going to get majority credit even if you do screw up a bunch of numbers in the calculator. But with that program, man, that's just a nice little extra little thing to kind of assure you you're going to get the right answer. But we're still looking for the work, making sure you know the formula and plugging numbers into the formula. Now, all in all, the last thing is this. You know everything about every problem on this test. Now, granted, some things may slip out your ear. I understand that. But don't leave anything blank. I mean, don't leave anything blank. Even people on my test, it just amazes me. On a multiple choice test, why would you leave anything blank? Doesn't make any sense to me. Granted, I didn't remember the formula for the power series for the tangent inverse. Shame on you, number 1. That was one of those things out of the 5 you're supposed to memorize. 2, you can at least guess. It's a multiple choice question. Why do you want to leave it blank for? Pay attention to things like that. And probably the case was you circled the answer on your test, but you forgot to bubble it in on the OpScan sheet. If you don't bubble it on the OpScan sheet, what you going to get? 0. We don't care. That's just called incompetence, and we just move on. Pay attention to what you're doing. Make sure. How long you got for this exam? 3 hours. You've got nothing to do. Sit back and enjoy this. Ride this pony for all it's worth. This is a wonderful exam experience. Knock yourself out for the next 3 hours. Don't try to finish it in 2 hours and be, woo, I was the first one who finished my class. Yeah, you're going to be a 32 on that exam too. All right? Take your time. Nail this thing. And now the last thing. I've seen your grades. Some of you guys are not as good as they need to be. Remember, this is calculus. And it's worse. It's calculus 2. Major competition. You understand, the engineering department, the science department, chemistry, biology, physics, math, all the science majors, computer science, engineering as a big group, these departments don't want you if you don't have the intellect to be able to get through this material. You have to compete with your counterparts. And as I was telling my class, here's what you really pray for. You pray you do awesome on this exam and everybody else bombs it. That's really what you want. It's not quite Christian, but that's the fact of the matter. It's really what you want in terms of this concept. Okay? So, at the end of the day, do your best. It is competition. Don't let this be the only exam you study. Remember, you study these exams for gathering information on how to do problems, memorizing formulas that you've long since left out your ear, things like that. Let's start doing this exam. Let's take a look at it. All right, so right off the bat, first thing, this is the no calculator part of the exam. Usually on the no calculator part is somewhere between 12 and 15 questions. They're going to hit you hard on basically a couple of things. Number one, at least 50% of this exam is going to be integration. Practice those integral skills. The other one is all that series stuff you just memorized. And that's the reason why I'm always going on the last day of class give my students a test on sequences and series, is because that's the most fresh thing in your mind and you don't have to really go struggle in terms of all this memorization. However, in my class there is some folks that didn't do as well on this exam as they should have. Class average on my exam on this last test was 70. And that was kind of sad because it looked just like the homework, because it was. All I did was copy the thing down again and change some numbers on it. So, what I'm going to do here is make sure you guys master this thing. After I do this exam, my goal is also to go over that test and show you that I could do that test in less than 30 minutes. Okay, because I've got 2.5 hours. I think I can finish this exam even with my long-windedness on talking to you guys. I can still finish this exam and give enough time to review that last little part that you should have known. It was little subtle things you weren't paying attention to that will catch you cold on this stuff. So let's take a look at this. All right, no calculator. Here we go. Also, at the end of this session, I will talk to my students about what I plan on doing in terms of attendance, the policy on having the final exam replace your lowest test grade connected to attendance, things like that. So I'll talk about some policy issues that I'm doing with my class that will help out a lot of folks in terms of doing the exam. Also remember this. For everybody in here, your final exam is worth at least 30% of your grade. This is huge. Huge. You cannot basically blow, even if you got an A in this class, you can't blow this exam off. Because if you blow it off and don't practice this thing, you'll walk away with a 52 on the exam or whatever, and I can pretty much guarantee you'll kiss your A away, and I've seen it kiss people's B away too. And then basically I had an A going into the exam and came out with a C. And don't kid yourself, that are people that are not quite A material that are struggling to keep that B or trying to keep a C in the class. This exam is huge. You've got to do very well on this exam. Very well. And we do look at it from a competition perspective. All right, here we go. On our mark, get set, go. Let's see how long it takes us to do part one. What's the first question they're going to give you guys? Integrate. Yeah, what a surprise here. What's the integral of 12x cubed minus 8x plus 3? And let me blow this up for you guys in the back. You can see this, and hopefully you got your copy on it. But this is pretty much straightforward. You do get the right on the exam. So 12 is a constant, leave it alone. Integral x cubed is x to the 4th over 4. Minus 8, integral x to the 1st is add 1 over add 1, x squared over 2. Plus the integral of 3 is 3x. And don't forget, plus c. Of course, they're going to clean this sucker up. This would be what? 12 divided by 4 is 3x to the 4th minus 4x squared plus 3x plus c, which is answer B. And hopefully, you already did this exam, so you're kind of going back and reviewing and just kind of double checking your answers. But if this is the first time you've seen it, well, here we go. Let's at least work it together. All right, this next one. Now, I'm going to let you guys know. I'm going to give you my personal opinion on this exam. This particular exam was mediocre. Okay. The amazing thing to me was things like this. Look at your next question. Now remember, we don't get a calculator. All right, that's fine. But here we go. You're supposed to integrate the sine of 4x dx. This is a rule you're supposed to have memorized. It's one of your special rules. This is the integral of the, in this case, the sine of kx dx. What is the formula for integrating the sine of kx dx? Well, integrate sine is what? Negative cosine. So this would be negative 1 over k cosine of kx plus c. Do you remember your famous k formulas? There was integral of sine kx, integral of cosine of kx, which is 1 over k sine of kx plus c, and the famous integral of e to the kx dx, which is 1 over k e to the kx. So, Putting this one in, to integrate the sine of 4x dx, the answer is going to be negative 1/4 the cosine of 4x plus c. And there's my answer. What bothers me about this one is, oh, it's not that big of a deal, but we don't have a calculator on this thing. Why mess up the students and try to give them things like 0.25 on it? Negative 1/4. What's the answer on this thing? Now, I know 1/4 is 0.25, and that's not a major stretch, as you should know. But my complaint to it is, if you're going to give them a no calculator section, we'll make the answer like a no calculator. I would like the answers to look like what I expect my students to get. Just my side point, but I didn't get to make up the exam. The answer on this one is clearly B. So we're going to critique this exam, and then I'm going to talk about, at the end, there was a few things missing on this exam, and because of that and my complaining, they've changed. So I'm going to try to help you guys out with, I know what they're going to do to you guys tomorrow on the exam. All right? So I'll talk about that again at the end of this thing. Number 4. Use 4 equal width trapezoids. Use the trapezoidal rule with n equals 4. Okay. To approximate the area under the curve of f of x equals x squared. All right. F of x equals x squared. You know, and we got n equals 4. The first thing you need to calculate is the delta x. This is that Riemann sum. They're going to either give you Simpson's rule, trapezoidal rule, or midpoint rule on this thing, and it's going to be on a no calculator part, which means the numbers should be relatively nice. So here we go. What's delta x? What's your formula? B minus A divided by n. Again, these things that while we're doing this, to remind you what we're doing, your A is 2, your B is 10. Here's A and here's B, so that'll be 10 minus 2 divided by 4. That's 8 divided by 4, which is equal to 2. All right? Typically, when I do this, I like to draw it out because I want to see my points. So we're starting at 2, but your delta x is equal to 2. So now let's do what my endpoints are going to be. From 2 to what? 4 to 6 to 8 to 10. So there's my B. There's my A right there. So these are my points that I have to worry about. Does that make sense? And with my delta x equal to 2, these are my partition points. Now, here's my question for you. Do you guys remember the trapezoidal rule? The formula for the trapezoidal rule was what? Again, while we study old exams and stuff. It is delta x divided by 2 times, what's the pattern? F of A plus 2 times f of x1 plus 2 times f of x2 plus 2 times f of x3 plus f of b. Just because we're studying for the final exam here, what's the formula for Simpson rule? Delta x divided by 3 times f of a plus 4f of x1 plus 2f of x2 plus 4f of x3 plus 2f of x4 plus 4f of x4 plus f of b. It's a 4, 2, 4, 2, and n must be what to use Simpson's rule? Even. That'll make you start off on a 4 and end on a 4 just before the end point. Remember the formulas. All right. So, my delta x is equal to 2. So this is 2 divided by 2 times f of a, that'll be f of 2, plus 2 times f of 4, plus 2 times f of 6, plus 2 times f of 8. These are my internal points, 4, 6, 8, but then your b is plus f of 10. What's my function on this thing? X squared. F of x is equal to x squared. So 2 divided by 2 is 1, no problem there, times f of 2. 2 squared is 4. Plus 2 times f of 4. 4 squared is 16. Plus 2 times 6 squared is 36. Plus 2 times 8 squared is 64. Plus 10 squared is 100. And I know everybody's itching to grab their calculator, but you can't. It's on the no calculator section. So what are you going to do? Multiply and add, the old-fashioned rate, just like the first grade. All right, so 1 times 4 plus 2 times 16 is 32, plus 2 times 36 is 72, plus 2 times 64 is 128, plus 100. Multiplying it times 1 is not going to change a thing here, but I am going to have to add. Again, me doing this problem, I look for patterns. Here's my pattern. What's 72 plus 128? That was nice. That's what? How much? 200 plus that 100, and might as well add these two guys together. What is 4 plus 32? 36. So I've got 36 plus 200 plus 100. That's not too bad. What do I get there? 336. I did not really need a calculator. Granted, it would have been awfully helpful, but I wasn't allowed, so that's just life. Does that make sense? The numbers weren't that bad, but they were large. But they weren't, you don't see me doing 4 7s plus 32, 96, 30, things like that. It'll be relatively nice numbers that they put. This was just a large group of numbers you had to add. All right, let's take a look at this next problem then. The integral of e to the 5x plus 2. Let me write it down here. The integral of e to the 5x plus 2 dx. This is not a form I have memorized, so what technique, the number one technique in integration you're going to use? Use substitution. What are you going to let u equal to? Exponent, 5x plus 2. What's du? 5 dx. Move the constant aside. 1/5 du equals dx. So when I substitute, this thing becomes e to the u, and the dx gets replaced with 1/5 du. And I always pull my constant out front. Don't forget to move the constant aside and substitute it. Where most people mess up use substitution techniques is they lose the constant. So you find u, you take du, move the constant to the side, the rest of it should be in the problem when you substitute. So I'm really substituting. There's the u, the dx is replaced with 1/5 du. Now this is a formula I have memorized. What's the integral 1/5 e to the u du? 1/5 integral e to u is e to u plus c. And then the last thing I'm going to do is back substitute. They didn't put bounds on this thing. So the answer is 1/5 e to the 5x plus 2 plus c, which is answer C. Does that make sense? All right. Cruising right along here. And this was something on your recent last test here. Which of the following is true about this series? This is sum as n goes from 0 to infinity of 5 over 2 to the n. When you got a series, you stop, pause, and hesitate and ask yourself, what kind of series is it? And double check these type of things by looking at the question and the answer. Which of the following is true about this series? They're talking about divergent, converges to number, converges to number, and converges to a number. There are only two types of series that actually we know exactly what they converge to without much work. What are they? Geometric and telescoping. Telescoping is this sum of a fraction minus a fraction where the numerator is the same. I don't see fraction minus a fraction in this problem. What's a geometric series? That's the sum of, don't care about constants, but numbers raised to just powers of n. And that's it. You've got just numbers raised to powers of n. What kind of series is this guy? It's a geometric series. 5 is a constant, that's okay, but it's got 2 raised to the n. Geometric series. Now, remember, there were two formulas for geometric series you should have memorized. There was the classic one we started in section 8.2 with. The sum as n goes from 1 to infinity of a r to the n minus 1. Or, if you want to make it look good, you can start with n equals 0 and go to infinity, and it'll be a just r raised to the n. They're the exact same formula. This was the one we kind of used with the power series stuff when we had it. But either one you want to use is fine, because here's the deal. Either form you're using, they're going to converge to a over 1 minus r if the absolute value of r was less than 1. It's going to diverge if the absolute value of r is greater than or equal to 1. Pure memorization on knowing your formulas. Which formula would I use on this one? Because this sum starts at 0, I would use this formula instead of this one. Now, if I could switch it to this formula, but I would have to add 1 here, which means I would have to subtract 1 from my ends within my problem. Remember the algebra on series. Does that make sense? But because this thing starts at 0, I use this formula. And then all I got to do is some algebra to clean this guy up. So this is the sum as n goes from 0 to infinity of 5. Now 2 to the n on the bottom, you can clean that up and it will become 1/2 to the n, right? 1 to the n is still 1. So I'm just trying to make this into an r raised to the n. 2 to the n in the denominator is the same thing as 1/2 to the n, because you can always times 1 and you can replace 1 with 1 to the n and then do your game on exponents. Does that make sense? But knowing that, I can see now that a is equal to 5, r is equal to 1/2. So, and the absolute value of r, which is equal to 1/2, which is less than 1, which means this thing is actually going to converge to the formula a over 1 minus r, which will be equal to a, which is 5 over 1 minus 1/2. Again, no calculators on this stuff, but I don't need it. What's 1 minus 1/2? And what's 5 divided by 1/2? Well, when you divide by a fraction, you invert and multiply, that'll be 5, pretty much flip it up, times 2 over 1, which makes it what? 10. It converges to 10, and the answer is E. Does that make sense? Questions? All right. Oh, here's a area problem here. The shaded region in the picture is bounded above and right by the graphs of f of x equals 8 minus x cubed, and below by the x-axis, and on the left by the y-axis. What's the area? Well, what's the formula for area when you're trying to find area under a curve type thing here, or between curves? Area between curves is the integral of top function minus bottom function dx from a to b. Or, remember this, it's right function minus left function, what? dy, and that means I would have to have y bounds. But this is clearly a top, bottom in my functions in terms of x. So the area would be equal to the integral. The function that's on top I see is the parabola. That would be 8 minus x cubed. Minus the one that bounds the bottom is actually 0 dx from, what are my points of intersection between the x-axis and my function here? You can count hash marks here. It's from 0 to 2. So my area, when you clean it up, is the integral of 8 minus x cubed dx from 0 to 2. That'll be 8x minus x to the 4th over 4 evaluated from 0 to 2. No calculators, but you got the famous fundamental theorem, plug in top minus plug in bottom. So this would be equal to 8 times 2 minus 2 to the 4th over 4 minus, when I plug in 0, well that's nice, I get 0. So now it's once again a bunch of number crunching. So this is equal to 8 times 2, which is 16, minus 2 to the 4th power. What's 2 to the 4th power? 2 times 2 times 2 times 2. 16. 2 times 2 is 4. Times 2 is 8. Times 2 is 16 divided by 4. Again, it looks nasty, but the numbers work out nice because I don't have a calculator, so you can expect that. What's 16 divided by 4? So I get 16 minus 4. And what's 16 minus 4? 12. The answer is D, 12. Does that make sense? And again, what I'm also trying to show you guys, as you guys are frantically copying this thing, is the work that we honestly expect you guys to do in doing these kind of problems. Okay? Take a look at the next guy. Find the integral from 0 to 9, 15 plus x plus 1 squared. All right, if I was going to do this problem, now here's the deal. Very important. I want to point this problem out to you guys because a lot of people died on this problem because they didn't do it the right way. I do not have a calculator. So I've got two ways I can do this problem. Personally, I see that integral from 0 to 9 of 15 times x plus 2 squared, and I'm just sitting there talking about plugging in numbers. You know, I got 9 plus 2 when I integrate type thing to a power. Well, that's 10. I can power up 10. That's no problem. So personally, I would do u substitution on this one. I will let u equal inside the parentheses x plus 1. du equals dx. So when I substitute, this becomes the integral of 15 is a constant. Leave it alone. This was u squared, and the dx actually is du. Hold the 15 there. What's the integral of u squared? U to the 3rd over 3, which when you clean it up would end up being 5u cubed. when you back substitute, you end up getting, 5 times x plus 1 cubed. And then, remember, this is equal to, when you evaluate it, from 0 to 9. Now, what am I going to use? Fundamental theorem of calculus. Plug in top minus plug in bottom. This is equal to 5 times 9 plus 1 cubed minus 5 times 0 plus 1 cubed. Cleaning it up, 9 plus 1 is 10. 5 times 10 cubed minus 5 times 1 cubed. Let's do some math in our heads. What is 10 cubed? 10 times 10 times 10. 1,000 times 5. So this is 5,000 minus 1 cubed is 1 times 5 is 5. So what's my answer? What's 5,000 minus 5? 4,995. Yep, that's pretty much it. The answer is C. But I wanted to address this problem. Did that make sense? I'll lose anybody anywhere. It's pretty straightforward, use substitution with bounds. But this is what caught students cold last semester. And I'm afraid it was a bunch of them were my students, because I taught you guys right from the beginning John's fundamental theorem of calculus. What's John's fundamental theorem of calculus? It's better to clean up your algebra before your calculus than afterwards. So I had a bunch of people foil this thing out. That gave me x squared plus 2x plus 1. And then they just left a 15 out front. Then they integrated each part. That gave them x cubed over 3 plus x squared plus x. Then they plugged in 9 minus plugged in 0. Well, what's 9 cubed? Oh, crap. They're sitting there working on the side of the paper, and they couldn't figure out what 9 cubed, because remember, no calculator and stuff. So the numbers became nasty because you didn't see that, when you add 1, it actually becomes nice numbers, so you should have used U substitution on this thing. Most of them got it right, but you spend an extra 5 minutes on trying to figure out the numbers on 9 cubed and adding the other numbers with 81 and things like that into the thing, and it didn't work out as well, and they were complaining about the no calculator part on this problem. But if you did use substitution, you didn't need a calculator because the numbers were nice. Keep that in mind when you're doing this stuff. Does that make sense? All right. I mean, don't get me wrong. You could have folded it out and cleaned it up and then integrated it, but by plugging in the numbers, it just didn't work out as nice in terms of the math. Look at this next guy. You've seen him before. You will see him again. I guarantee it. It is the integral of x times the sine of x. Now, I can go through the steps of showing you why it's this particular problem, but you need to know. On the integral of sine or cosine of x dx, what method of integration are you going to use? Integration by parts. Problem recognition here. The reason why, if I was going to do U substitution, this isn't a formula I have memorized, I would let U equal to angle inside the parentheses x, but you never let U equal x in U substitution. I would let U equal to sine of x, but derivative of sine of x is cosine of x, which is not in the problem. So all the tricks of U substitution aren't going to working, and it's a product. But recognize this guy. We've done him about 14 times in class. You've seen this guy before. This x times the sine of x or cosine of x, and usually put a 3x or 2x or something on it. That is an integration by parts. And what is your formula for integration by parts? Integral of u dv equals uv minus integral of v du. All right? So with this one, if I'm trying to integrate x sine of x dx, what are you going to let u equal to? What are you going to let dv equal to? What should you always let u equal to? Because remember, you let u equal to things, when you take its derivative, they go away. What would you let u equal to? X. That forces the dv to be the sine of x dx. You need to take the derivative of u to get du. What's the derivative of du? What's the derivative of x? 1 dx. But you have to integrate dv to get v back again. What is the integral? Watch this and make sure you get it right, because this is where students screwed it up at. What is the integral of the sine of x? Negative cosine of x. If you do not have these formulas memorized, you will be sitting in this class again next semester. You've got to know this stuff. And I know it's real easy to make a careless error, but let me tell you, what's the careless error? Well, the integral of sine of x is actually the cosine of x. Well, no, that's wrong, but if you use that, you know one of these answers is one of those problems, because that's a classic mistake. And they're setting you guys up for that. They're trying to check to make sure you've mastered this material. The integral of sine of x is negative cosine of x. Plugging into my formula, u times v, that would be x times negative cosine of x minus integral of v, which is negative cosine of x, du, which is dx. And literally, I just plugged it into my formula here. Now, of course, before I integrate, I'm going to clean them up. This will give you negative x cosine of x. A minus is a plus. The integral of cosine of x dx. So now, all I've got to do is, what is the integral of cosine of x? Sine of x. So that would be plus sine of x plus c. And this would be negative x cosine of x just being pulled down. And there's my answer. Now, the other last thing is this. When you're doing this particular problem here, pay attention and be careful and make sure you pick the right guy out of the lineup. So who is your answer? Answer is E. Does that make sense? Questions? Classic improper integral. Now, honestly, I could do these problems in about 10 seconds or less if I was working at it on my own. But since I'm trying to remind you guys of stuff, and I'm also trying to prepare you for the free response part of the exam where they're going to expect you to show great details of the work and how to do the problems and stuff, I'll do every problem in great detail. Here's the deal. What kind of integral is this guy? Because I got that infinity on the bound. Improper. How do you turn an improper integral into proper mathematical techniques? Well, I can't plug in infinity. Infinity is not a number, it's an idea. So what we do is we pick our favorite letter, limit as a, that's my favorite letter, goes to infinity of the integral from 1 to a. I'm going to clean this guy up of 6x to negative 3 dx. Still got to integrate the thing, but the integrating this guy is no problem. Limit as a approaches infinity of, 6 is a constant, integral x to negative 3 is add 1 over add 1, 6 to negative 2 over negative 2, evaluated from 1 to a. And again, I'm trying to show you, if this was a free response question, which it could be, how I would expect to see it written up for full credit. Cleaning this guy up, this is equal to the limit as a approaches infinity of negative 3 over x squared. 6 divided by negative 2 is negative 3. X is negative 2, negative exponent goes on the bottom. Evaluated from 1 to a. So this is the limit as a approaches infinity of negative 3 over a squared minus negative 3 over 1 squared. Fundamental theorem of calculus, plug in top minus plug in bottom. This would be equal to the limit as a approaches infinity of negative 3 over a squared. Negative makes it a positive. 3 divided by 1 squared. 1 squared is 1. 3 divided by 1 is actually 3. But now take your limit as a approaches infinity. When a approaches infinity, you're going to get negative 3 over infinity squared plus 3. Infinity squared is infinity. When it's on the bottom, though, what does the fraction go to? 0. So what do I get? And we would write it as, because it's improper, we let that answer noted by using words like convergent or divergent. If you get infinity answers, it's divergent, but if you get a numerical answer, we say it's convergent to 3. Does that make sense? And so the answer is C, 3. But again, I'm going great details because if this was a free response question, this is what we would expect to see. Does that make sense? All right, here's another classic problem right off of your old test from like a week, 2 days ago. What is the coefficient of x cubed in the Maclaurin series expansion of e to the negative 2x? All right. This is one of these ways on multiple choice questions they can ask you about Maclaurin or Taylor series or whatever the case may be. So, what I have to do here is I've got to come up with the Maclaurin series for e to the negative 2x. Now, you've got all this stuff memorized about the formula. Maclaurin series is f of 0, because Maclaurin series is Taylor series centered at 0. F of 0 plus f prime of 0 over 1 factorial times x plus f double prime over 2 factorial times x squared plus f triple prime over 3 factorial times x cubed, so forth and so on. All right, that's great. And you could sit there and do all these derivatives if you want to, but here's the deal. There were 5 Maclaurin series we expect you guys to have memorized. Those series that you should have memorized because it's going to at least give you 10 points on this exam, is 1 over 1 minus x, the sine of x, the cosine of x, e to the x, and the arctangent of x. You should have every one of those Maclaurin series memorized. This is one I have memorized, but I don't have e to the negative 2x memorized. What do I have memorized? E to the x. What is my Maclaurin series for e to the x? It is 1 plus x over 1 factorial plus x squared over 2 factorial plus x cubed over 3 factorial plus x to the 4th over 4 factorial plus dot dot dot. Okay? Pure memorization, but this is why we love power series. They're easy to manipulate. Well, that's not the dude I want. What dude do I want? I want e to the negative 2x. So what am I going to do? I'll replace all my x's with negative 2x. So this will be 1 plus negative 2x over 1 factorial plus negative 2x squared over 2 factorial plus negative 2x cubed over 3 factorial plus negative 2x to the 4th over 4 factorial plus yada yada yada. Okay? So cleaning this guy up, this gives me e to the negative 2x being equal to 1 minus 2 over 1 factorial times x. Now inside parentheses I'm going to distribute because it's multiplication, my power. What's negative 2 squared? So that'll be plus 4 over 2 factorial times x squared. What's a negative 2 cubed? Negative 8x cubed over 3 factorial. Negative 2 to the 4th power is a positive. Negative 2 to the 4th is 16. X to the 4th over 4 factorial plus dot dot dot. But I don't care. What do they want me to find for them? They want me to find the coefficient of x cubed. So there is my x cubed term. So the coefficient of x cubed is what? Negative 8 over 3 factorial. But be careful on that one. What is 3 factorial? 6. 3 times 2 times 1. So this is negative 8 over 6. But of course, no calculator on this thing, so I'm going to have to reduce this fraction on my own. What is 8 divided by 6 also known as? It'll be negative 4/3. So the answer is A, negative 4/3. Does that make sense? Again, I'm trying to go out of my way to show great details because a lot of these questions are not just questions on multiple choice. They could put a version of this question on the free response, and this is what I would expect to see. Questions? All right? Look at this next guy. Problem recognition, once again, is the key. I want you to integrate 5 over x squared plus 4 dx. Well, that is a formula I have memorized. Couple of things you should know. I've got a polynomial in the denominator. It's a proper fraction, but the denominator doesn't factor. If it factored, then I would use partial fractions. Denominator doesn't factor, and it's a square. I got a formula for that guy. And that formula that I have memorized that I'm always looking for is the integral of 1 over u squared plus a squared du. What's it equal to? It's 1 over a arctangent of u over a plus c. The famous arctangent formula. They are going to give you a problem like this because this is one that flipped out of people's ears that they're supposed to have memorized. So, in this particular problem, I've got the integral of 5 over x squared plus 4 dx. 5 is a constant. Constants go out front. So this is 5 times the integral of 1 over x squared plus 4 dx. That makes it nice because here u squared would be equal to x squared. That makes u equal to x when I take the square root of both sides. But remember, we're using a formula like this. It's from the back of the book we have memorized. Du is u substitution, so you've got to use the du. But the du is equal to dx. Also, a squared had to be 4, making a equal to 2. So when I substitute, this thing actually becomes 5 times the integral of 1 over u squared plus a squared du. So it's going to be 5 times the formula that I have memorized. 1 over a arctangent tangent of u over a plus c. So now I'm going to write it over here as I plug it in. It would be 5 over a. What's a in this problem? 2 times the arc tangent of u, but u equals x over a, which is 2 plus c. There it is. So, which one is this one? 5/2 arc tangent of x over 2. The answer is clearly which one? C. Again, you can see the purpose of us going over these old final exams is to remind you of the formulas. Yes, ma'am. Is that better? Okay. Questions? All right. Now, take a look at the next one. Just like I and Desiree and I'm sure Wafa and Beth and Kelly put on their test, this is the type of way we typically give you guys the integrals from the back of the book tables. We'll give you one of them. This is the dude you'll have to use, and don't argue with us because we really are right. This is the formula I have to use. I've had students come up to me during an exam going, "Dr. Taylor, they're wrong." Really? Yeah, that's not the wrong formula for that formula. And usually they screwed up because of the DU type thing here. And so, but trust us, we've gone over the exam, probably. So I don't think this really. I do think this really is the formula. So here it is. We're supposed to integrate 1 over the square root of 4x squared minus 1 dx. Remember, when you're using tables, it's based upon the concept of u substitution. And right there is they're signaling to you what the u, or in this case u squared's got to be as you compare. In this problem, the u squared would be equal to what? 4x squared, and then it's keeping up with that constant where people will screw this problem up at. What would that force u to be equal to? Take the square root of both sides, 2x. But it is u substitution. After you figure out what u is, don't forget, du, move constant, u substitution. So what is du? What's the root of 2x? 2 dx, move the constant on the side, that means 1/2 of du equals a dx. So when you substitute, this problem now turns into 1 over the square root of, there's my u squared, this was a -1 constant that's supposed to be in the problem which matches up. That's fine. But the dx, and here's the trick, gets substituted in for what? 1/2 du. So when you clean this thing up, where's that half going to go being a constant? Front of the integral. 1/2 the integral of 1 over the square root of u squared minus 1 du, which is equal to 1/2 of, and now I'm plugging my formula, the natural log of the absolute value of u plus the square root of u squared minus 1 plus c. And then the last thing I'm going to do is, again, what you had to do really was to keep up with the constant. So you know it's going to be some answer looking like natural log of u plus the square root of u squared minus 1. So, you know, that's pretty much what the answers are going to look like. So just keep up with the constant out front. So this is equal to 1/2 the natural log of the absolute value of u, which is, what was u equal to? 2x plus the square root of u squared, which is 4x squared, minus 1, close absolute value, plus c. And there's my answer, which is, which answer? I believe it's A. And look, and again, common mistake. It's got the 1/2 out front, but two of them have 1/2 out front. But this one has a 2x inside for the u. This one has an x for the u. Which one was ours? The 2x was the u. The answer was A. Does that make sense? On this particular exam, part 1 had 15 questions. Take a look at this next guy. And I just talked about this just a few seconds ago. I want you to integrate 4 divided by x squared minus 9. I'm trying to integrate a fraction, but this time, look at that denominator, x squared minus 9. What do you notice about that denominator? it's not a plus. This is not the arctangent formula. It's a minus, which means the denominator does what? Factors. So I'm trying to integrate this guy, but this 4 over x squared minus 9, I noticed that the denominator factors, so this would be equal to 4 over x plus 3 times x minus 3. And when I want to integrate a proper fraction, proper being the degree of the denominator is bigger than the degree of the numerator, and the denominator factors, what technique do I want to use? Partial fractions. I want to bust this thing up. And again, partial fractions is a huge technique that you will see again in differential equations. It's better to do calculus on small fractions than it is to do it on big fractions. This is a big fraction, but with the technique of partial fractions, I get to bust this thing up. So this is equal to a over x plus 3 plus b over x minus 3. Does that make sense? Now, I'm going to multiply by my common denominator of, and this particular problem here, x plus 3 times x minus 3, and that's going to give me the equation 4 is equal to a times multiplying a divided by x plus 3 times x plus 3 x minus 3. I get a times x minus 3 plus b times x minus 3 cancels, b times x plus 3. I taught my class the Annihilator Method, and the Annihilator Method is, this thing works, once you clear denominators, it works for all x's. I suggest you using the best numbers for x's to plug in. What numbers for x's would you plug in on this thing? I would plug in 3 and negative 3. When I plug in 3, all right, when I plug in 3 on this guy, I'm going to get 4 is equal to a times 0, 3 minus 3 is 0, plus b times 3 plus 3, which is 6. And so that goes away. And to solve for b, I would divide by 6 on both sides, making b equal to 4 6, but 4 6 is also known as 2/3. When I plug in negative 3, I'm going to get 4 equals negative 3 minus 3 is negative 6 times a, plus officially b times 0, which goes away. Solving for a, I'm going to divide by negative 6 on both sides, and I'm going to get negative 2/3 equals a. Does that make sense? So, this problem, again showing all the grandiose details here, now turns into the integral of a, which is negative 2/3 over x plus 3, plus b, which is a positive 2/3 over x minus 3 dx. Now, we've done tons of these partial fraction problems, and we do expect you guys to have the ability to do, quote, U substitution in your head. This one is a classic U substitution in your head. What would you let U equal to? The denominator, x plus 3. So du would be dx, because you can break this up into actually two integrals here. And so this becomes negative 2/3 is a constant, leave it alone. Integral 1 over u is what? Natural log, officially, absolute value of u, which is x plus 3. This is u substitution in your head. Plus 2/3 is a constant. This would be integral of 1 over x plus 3. You let u equal, x minus 3. You let u equal x minus 3. du equals dx. So this is again 1 over u, which is the natural log, the absolute value of u, x minus 3. And don't forget your plus c. So there's my answer. And now go back way up here to the problem to figure out which one it's going to be, when there's only one that has natural log minus natural log with some 2/3 in it. So pretty much once I got that 2/3 thing, I pretty much could have quit. There's the answer right there. Does that make sense? Again, I'm really working hard on the review aspect of this thing. Don't let this be the only exam you guys do. There's other reviewing you need to do. Take a look at number 14. This is a chapter 5.1 to 5.3 kind of question here. Suppose f prime of x is equal to 12x cubed minus 5, and f of 1 equals 12. What's f of 0 going to be? Well, here's the thing. This is one of those first things you learn right from the get-go, and that is this. They want to know something about f. If I need to figure out what f of x is, and they give me f prime of x, I need to integrate f prime of x dx. So f of x would be equal to the integral of f prime, which is 12x cubed minus 5 dx. which is what? Well, 12 is a constant, leave it alone. What's the integral of x cubed is add 1 over add 1, x to the 4th over 4. Minus the integral of 5 dx is 5x. But don't forget, there's no bounds on this stuff, so you've got to put that plus c. So that tells me that f of x is actually 12 divided by 4 is 3. 3x to the 4th minus 5x plus c. But to figure out anything about a function, you got to know what that c is. That's why they gave you what we call initial condition. Again, these terminology I'm using will also be used in differential equations. They gave me the initial condition that f of 1 equals 12. This information is just used to solve for c. So I'm going to plug in x equals 1, I'm going to set it equal to 12. So f of 1 would be equal to 3 times 1 to the 4th minus 5 times 1 plus c equals 12. Solving for this thing, 1 to the 4th is 1, times 3 is 3. 5 times 1 is 5, so 3 minus 5 is negative 2 plus c equals 12. What does that make c equal to? Add 2 to both sides, you get c equals 14. Does that make sense? Therefore, my answer, a little 3 dots, f of x equals, therefore my answer f of x is actually 3x to the 4th minus 5x plus 14. I'm going to circle that guy, but I'm going to write him over here because I ran out of room because of that other problem. That's all right. So what do I get for f of x? F of x was equal to 3x to the 4th minus 5x plus 14. They want to know what f of 0 is. What do I got to do to figure out what f of 0 is? Plug in x is 0. That'll be 0 to the 4th, which is 0 minus 5 times 0 plus 14. What am I going to get? 14. So f of 0 has got to be 14, which is my constant. The answer was D. But you had to go find the function first to figure out what f of 0 is. And f of 0 ended up being that constant I found. Does that make sense? Questions? Which of the following is the derivative of this guy? Again, this goes back to section 5.4, the other fundamental theorem of calculus about taking the derivative of integrals. So I got some weird function f of x, which is equal to the integral from 0 to 3x of the tangent of 4x plus 1 dt. The question is they want to know what the derivative of f of x is. They want to know what f prime of x is. Well, to find the derivative, I need to take the derivative with respect to x of this integral from 0 to 3x times the tangent of 4x plus 1 dt, 4t plus 1 there, dt. So here we go. What's the big deal about the fundamental theorem of calculus, the other version of it? The derivative of an integral, you don't go anywhere. Get the original function back, right? But when you got the variable, so there's my variable up there at 3t. So I'm going to plug in 3x. I'm going to plug in 3x for all my t's. But because it's something other than just x, I got to use the chain rule version of this thing. So the derivative and the integral cancel, so I'm left with just the function tangent of 4, but we're plug in top minus plug in bottom type thing here. The 3x gets to go in for the t, so that'll be 3x plus 1. Okay? But then you've got to do times the derivative of the inside, but the derivative inside is just 3. So when you clean it up, I get 3 times the tangent of 12x plus 1. And that'll be my answer. Now, that being said, people ask me, well, what happened to the 0? Well, officially, you plugged in 0, but then you got to do times the derivative of the inside. And because that chain rule version times derivative of the inside, what is the derivative of 0? It's also 0, and you multiply 0 times any function, it goes away. That's why anytime you have a constant on these bounds, that when you take the derivative of it, the constant ends up going away because the derivative of constant is 0. That's the reason why. So it's just derivative integral cancels. You plug in your function times the derivative of that function, and that'll be your answer. Does that make sense? Which makes this answer equal to which one? Answer is B. Now, there's my part one, completely done, without over detailed explanation with that thing. I'm on to part number two. That first part, remember, you've got a 3-hour exam. You do not get to use your calculator until, one, your professor states you're allowed to use a calculator. Two, everybody had to turn in part number one. And number three, you got an hour to do part number one. You've got an hour to do part number one. They really break this thing up to be an hour each section. But I've even stopped a wee bit early on this thing, okay, compared to when I actually started this review. But now I'm going on to part number two. But yet, it's probably about 15 more minutes before I'm actually allowed to use my calculator. Well, let's take a look at this thing. You'll see, even on part number two, and this will happen to you, I don't have options to use my calculator yet, but honestly, most of the problems on this thing, you won't need a calculator. Some of them will. Eventually, I'll grab this thing, but right now, for the next 15 minutes, I can't use it. So here we go. Look at this problem here. Which of the following which of the following definite integral will give the volume of the solid obtained by rotating the area bounded by the graphs of f of x equals 4x and g of x equals x cubed? And they went ahead and graphed it for you again. So the 4x is the dude on top, so you didn't have to use your calculator to graph this thing. 4x, and the function on the bottom is the g of x part, which is x cubed. But they want me to rotate it around the x-axis. And here's my x-axis. Now let me understand what's going on here. My functions are clearly in terms of x. And they wanted me to rotate this region bounded by these functions around the x-axis. What method will I use? Very good. Disk washer. Functions in terms of x, rotate around the x, disk washer. Functions in terms of x, rotating around the y-axis, shell method, or something parallel to the y-axis, shell method. Does that make sense? Remember those rules. So disk washer, what was your disk washer formula? Volume equals pi times integral of big radius squared minus little radius squared, these are functional radiuses, dx from a to b. To figure out what your big functional radius is, you go from the axis of rotation to the outside edge of your region. So I'm trying to envision, there's my axis all the way to the outside edge. But the outside edge is 4x. So this x-axis is officially y equals 0. So this distance would be 4x minus 0, which is just 4x. So your big radius is 4x. Your little radius is from the axis of rotation to the inside edge of your region. It's the top minus bottom. The inside edge is from the axis is x cubed minus 0, or just x cubed. Again, top minus bottom. So I plug it into my formula. Volume is equal to pi times integral of big radius, which is 4x squared, minus little radius, which is x cubed squared, dx over my bounds. And it looks like we're bounding it between 0 and 2, and pretty much that's every answer on the test there. So I'm real confident that's now between 0 and 2. But you'll notice that this is not how they wrote up my answers. All these 2 pi problems, it tells me these are the shell method problems, and I should not be using the shell method on this one. This is a disk washer method. So clearly A and B are completely out. And also D is out, which means the only answer has got to be C or D. Does that make sense? Clean this stuff up. As long as it's strict multiplication division, you can distribute. So volume would be equal to the integral from 0 to 2. And there's my pi, and they seem to put it on the inside, so will I. 4x quantity squared would be 16x squared minus x cubed squared, power to a power multiply, that'll be x to the 6 dx. And there's my answer right there, which is answer which one? 16x squared minus x to the 6 with a pi out in front, not a 2 pi. It's got to be answer D. Pay attention to the format. Does that make sense? Lose you guys anywhere? All right. Great review. Oh, series problem. Here we go. Consider the Consider the infinite series. The sum as n goes from 1 to infinity of 1 over n cubed plus 1. Which of the following tests results in a successful determination of the convergence or the divergence of the test? So look at this example. Again, you're also studying these type of tests for how they word stuff. Because let me tell you, it's the same dudes making up the committees every time. There's one guy that's in charge, that responsibility rotates, and then the other committee members are on it, and basically it's the same committee, they just rotate who's in charge of this thing, and who makes it up, and who gets to identify this stuff. And they really do look at a few semesters ago, last semester, and the semester before it, and the semester before it, to actually get an idea to make up the exam. Here's a classic problem right here where I have to actually go through the answers. So, going through these answers, how would I do this problem? The sum as n goes from 1 to infinity of 1 over n cubed plus 1. Well, personally, I would do a comparison test on this one. And what would I compare it to? I didn't say it could be a direct comparison test or a limit comparison test. I have options with this stuff. But a comparison test, we would compare to what? 1 over n cubed, sum as n goes from 1 to infinity. What's that sucker's name? P series. What's P equal to? 3. P equals 3, which is greater than 1, which tells me this series does what? Converge. So, and this is what I taught my class, or at least tried to, this idea of the mental comparison test. I already know what the answer is. If I would compare it to this dude, and since this dude converges, guess what this guy's going to do? Converge. So right now, any answers that say divergent on, I can chuck them out the window. All right, anything that says divergent, you bet. D's out, B's out. Narrowed down my answers down to 3 choices now, because I got a brain. Does that make sense? Now, let's go through the rest of them to figure out, all right, we know it converges, so it's got to be convergent. And then what test would I use? Converges by the ratio test. Would you ever use a ratio test on this problem? No. Why not? No factorials, no powers of n, no way. Wrong answer. Does that make sense? Converges by comparison test using the sum as n goes from 1 to infinity of 1 over 2n. There's lots of problems with this one. The first problem is, what should you compare to? 1 over n cubed. This is not 1 over n cubed. This is wrong. The other reason why this is wrong is 2 is a constant, goes out front. So this is really the sum of 1 over n. What's that series? Harmonic. What does the harmonic series do? And you'll never get convergent off of a divergent series. So this is just stupid all the way around. So that's wrong. Does that make sense? And look at the last one. Converges by the comparison test using 1 over n cubed. Well, that's pretty much what I did. So that's definitely my answer. Does that make sense? Use what you guys know. All right? Again, another reason why we study the old final exams. What's the formula for arc length? They want to know in this problem, which of the following gives the length of the curve of y equals x to the 4th minus 2x on the interval between 1 and 5. Now look at this thing. They didn't ask me to integrate it. They just want to know which integral gives me the arc length, which means this is a question of whether you know what the formula is. Let's go through it. What is the arc length formula? Now this is a function in terms of x. We actually had 3 formulas for arc length. It was the integral from a to b of the square root of what? 1 plus the derivative of your function squared dx. The other arc length formula was this integral from c to d of the square root of 1 plus the derivative with respect to y of your function squared dy. And the other one was the parametric form, the integral of the square root of dx over dt squared plus dy over dt squared dt. But this is a function in terms of x. This is my dude. So now I just have to do what f of x is. F of x and y are the same thing, which is x to the 4th minus 2x. But I need its derivative. The derivative of x to the 4th is 4x cubed minus derivative of 2x is just 2. But of course they're going to make you jump through some hoops on this one. They don't give you anything for free. So arc length is equal to the integral of the square root of 1 plus 4x cubed minus 2 squared dx from 1 to 5. Well, there's my answer, but look, that's not one that matches up. Why? Because they're going to make you clean this thing up. Algebra. How do I clean up 4x cubed minus 2 quantity squared? I'm going to use the FOIL method. So arc length would be equal to the integral from 1 to 5 of the square root of 1 plus, folding this thing out, 4x cubed squared. Well, I got to square each term, so 4 squared is 16 x cubed squared is power to a power multiplied, that'll be x to the 6th. Minus this times this, doubled. 4x cubed times 2 is 8x cubed. Double makes it 16x cubed. Plus last, negative 2 times negative 2 is 4. Now, of course, they want to combine like terms, so I'm trying to show you exactly what the answer is. Don't forget that dx on the back of it. So this gives me that arc length is equal to the integral from 1 to 5 of the square root of 16x to the 6th minus 16x cubed. 1 plus 4 is plus 5 dx, which is answer E. Does that make sense? But the most important thing was the algebra, great, but it really was knowing this formula here, arc length. Does that make sense? Again, another one of these series questions. Which of the following is true about the series of sum as n goes from 1 to 0 of negative 1 to the n divided by 3n plus 1? Okay? Well, first off, this is an alternating series. So officially, I would use the alternating series test on this thing. But usually with an alternating series, they ask me the weird question about, is it absolute convergent, conditional convergent, or diverges? But they didn't ask me that here. If they did, I would start with the absolute value thing and figure out this is 1 over 3n plus 1, and that looks kind of like a harmonic series to me, which would diverge, and this thing would not be absolute convergent. And then I really would have to use the alternating series test. But look at the way they wrote the questions. So when you got these series questions, always look at their answers and what they want you to do. It diverges because, it diverges, it converges, it converges, it converges. So they really want to know if it converges or diverges. So the first thing, because it's an alternating series, is I'm going to use the alternating series test on this thing. The Bn part is the part without the alternation, which is 1 over 3n plus 1. Couple of things here. We're starting with n equals 0 on this one. So the first thing I'm going to check is plug in my numbers, but they did start with n equals 0. N is 1, n is 2. Let's plug it in. This will be 1 over 3 times 0, which is 0, plus 1 is 1. Plug in 1. This will be 1 over 4. Plug in 2. 3 times 2 is 6, plus 1 is 7, 1 over 7. And dot, dot, dot. The terms seem to be going down. Big old check there. And number 2, when I take the limit as n approaches infinity of the Bn, which will be equal to the limit as n approaches infinity of 1 over 3n plus 1, I get 1 over 3 times infinity is infinity plus 1 is infinity, and 1 over infinity is 0. So the terms go down according to the alternating series, and the limit goes to 0. Can you tell me what this thing's going to do? It's going to converge. Does that make sense? It's going to converge. So pretty much, you can blow away A and B. But now here's my question. Does it converge to a positive number or to a negative number? Why do I figure it out? Well, it's an alternating series. Let's do some kind of partial sum. Let's see what it goes to. And the true sum is just going to follow along with some extra decimals on it. So I'm going to do something like, let's just do an S4. Let's do a partial sum on this one to see what the partial sum is, and that's going to give me an approximation to the answer. Does that make sense? So we're starting with n equals 0, so this would be n equals 0, n equals 1, n equals 2, n equals 3, and n equals 4. Okay? With S4, you officially use not just the first 4 terms, but you stop with n equals 4. So this happens to be 5 terms. So let's just plug it in on this thing. What's negative, right here. Negative 1 to the 0 power is 1. 3 times 0 is 0, plus 1 is 1. So this thing is 1. When I plug in negative 1, that'll be negative 1 to the first, which is negative, over 3 times 1 is 3, plus 1 is 4. That'll be negative 1/4 when I plug it in. Plus, now negative 1 squared is positive. 3 times 2 is 6, plus 1 is 7. That'll be 1/7. Negative 1 cubed is back to negative. 1 over 3 times 3 is 9, plus 1 is 10. Plus, negative 1 to the 4th is back to positive 1. 3 times 4 is 12, plus 1 is 13. plus dot, dot, dot. But now, and by this time, I'm allowed to have the calculator. If I wasn't, I would move on to the next problem and come back to this guy later until when I'm saying, it's okie dokie to use the calculator thing here. So now, here we go. I've got 1 minus 1 over 4 plus 1 divided by 7 minus 1 divided by 10 plus 1 divided by 13. Good enough. What number did I get? I got some weird number, 0.86978022198. But this approximates, not the exact answer, but at least tells me what I need to know. What's it converging to? Let me blow it up so you guys can see in the back here. So I've got a choice. Converge to a negative number, positive number, or is it converging to 0? This is clearly not 0, or even close to 0. It's 0.86. So, but it is a positive number, so the answer is actually, oh, whoops, wrong one. The answer is actually D. Does that make sense? Converges to a positive number. Don't lose you guys anywhere. Does that make sense? Here's a sequence one. This should be about 10 seconds. Which of the following is true about the sequence where AN is equal to 2m plus 3 over 5m plus 4? Well, they're doing a limit as n approaches infinity, so I'm going to do the limit as n approaches infinity of 2m plus 3 over 5m plus 4. Officially, when I plug in infinity, I'm going to get infinity over infinity. So I would use L'Hopital's rule, or just look at it and tell me what the answer is. 2/5. L'Hopital's rule, take derivative of the top, derivative of the bottom, which is 2 divided by 5. Yeah, which is the answer? B. Does that make sense? That was a free one. All right, so number 6 here. The only information. All right, we'll read this problem. They stole it off of WebWork. Let you guys know where this one came from. The only information known about a function f of x that is provided on the table of values shown below. Estimate the value of the definite integral from 0 to 2 using Riemann sums. So we're going to have my interval is from 0 to 2 is divided into 4 subintervals of equal widths. 4 subintervals. So that tells me n equals 4. So I have to read the paragraph here to figure out my numbers. And of course, they even throw it in your face. You'll be using the midpoint of each interval to create this thing. So if they gave me the interval from 0 to 2, and they said n equals 4, I can immediately calculate my delta x. We're doing Riemann sum type stuff here, which is b minus a divided by n, which will be 2 minus 0 divided by 4. That would be equal to 1/2. 2 minus 0 is 2 divided by 4, 1/2. So my interval partitions have a delta x of 1/2. Delta x is equal to 1/2. So I'm going from 0 to 1/2, 1/2 to 1, 1 to 1.5, and 1.5 to 2. But then they said the magic words, use the midpoints. I want you to use midpoints on this thing. So you partition this guy out, but you notice we skipped over a number, so when they want me to use the midpoints, we're talking about the midpoint at 0.25 is 2.5, at 0.75 is 2.8, at 1.25 is 0.5, and 1.75. These are the midpoints of each interval. Does that make sense? So the midpoint Riemann sum formula, n, is equal to delta x times f of x1 with a little bar over it, because you're supposed to use midpoint of that region, plus f of x2 bar plus dot 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 plus f of xn bar. This was the formula that you have memorized from chapter, what was it, 5.3, and then again 6.5 or something like that. And they did Riemann, Simpson's, and Trapezoidal Rule. So here's the deal. What's delta x equal to? For the midpoint for 4, your delta x was equal to 1/2 times f of the x coordinate of your first midpoint, which is 0.25, plus f of your second midpoint, which is 0.75, plus f of your third midpoint, which is 1.25, plus f of your last midpoint, of 1.75. So midpoint, don't forget the delta x 1/2 out front. F of 0.25 using the chart is 2.5, plus 0.75 is 2.8, plus 1.25 is 1.5, plus 1.75 is 5. And now, these are not nice numbers, but this is in the calculator section, and by now I definitely have plenty of time to use the calculator. So this would be 1/2 times 2.5 plus 2.8 plus 1.5 plus 5. Notice I'm trying to make my calculator, no careless errors, look exactly like what I'm trying to type it in there. And what do I get? I get midpoint rule for 4 is 5.9, which is answer B. Does that make sense? Did I lose you guys anywhere? All right. Now, let me tell you something about this exam, which this is what I complained to the committee about. It was very light in 2 areas. Light meaning they didn't put any questions on 2 areas, which areas that we spent a lot of time on. And those 2 areas were spring problems and pumping problems. They didn't put any spring problems or pumping problems on this exam. So I complained to the committee saying, we spent a lot of time trying to cover that stuff. And in previous exams, they usually put these guys were your big point totals. And then all of a sudden, they've kind of been absent for the last couple of exams. That's why on my Moodle sheet, I put in section, from 2012 exams and things like that, because they had pumping problems on those things. So at the end of this thing, I'm going to do a pumping problem for you because I have been assured you will be seeing a pumping problem tomorrow. Now, I don't get to see the exam. It's part of the policy of the university. The professors that teach the subject matter don't get to be on this committee. So I've only been on this committee one time in the last 6 years. That's because I've only been one time I haven't taught Calculus 2 in 6 years. God help me. But the fact is, I'm not on that committee, but my advisor is. So I get to talk to these guys regularly about this stuff, and they've assured me we're going to see a pumping problem on this one. So practice your pumping problems. It will be big point totals again. All right. Yes, ma'am.
Any spring problems?
Yes, ma'am. So I'll do one of those 2. Okay. And some sequences and series. So, and I'll talk about what I know and try to help you guys out with the sequences and series. About alternating series, and when you got an alternating, whether it's a power series or not, when it's alternating and you cut it off, your error is always the next term up. That was the alternating series estimation theorem. Make sure you review that, and I'll talk about that again in a minute. All right, here we go. Look at number 7. This was at least a Chapter 7 problem, is why I brought this fine fact up to you guys, because you needed to know this. An object on an x-axis is subject to a force of x squared plus 4 pounds, with x measured in feet. How much work is done in moving it from x equals 1 foot to x equals 10 feet officially? And a lot of people died on this problem. We can go back and we analyze the data on each question. This was the question that people were just didn't remember. And it was sad because it was the first rule of work that we talked about. Well, okay, it was the second rule. First rule of work was work is equal to force times distance. But once your forces are changing, you get the formula. That's where we get those spring problems and things like that. Work is equal to the integral of force dx. We created the whole spring formula for work, because force equals kx Hooke's law with springs. We got the integral of kx dx when it comes to springs. But this was the basic formula that started it all. Work is equal to the integral of force with respect to x, as x is your distance that is moving. Does that make sense? So it's a real simple problem once you know the formula. This is just the integral from 1 to 10 of x squared plus 4 dx. This is equal to the integral of x squared is x cubed over 3, plus the integral of 4 with respect to x is 4x, evaluated from 1 to 10. This will be equal to 10 cubed, fundamental theorem of calculus, plug in top, over 3 plus 4 times 10. minus plug in 1, 1 cubed over 3 plus 4 times 1. And honestly, once I'm doing this, I'm going to sit there and plug these numbers on my calculator here. And when I plug them into my calculator, I get 369. 10 cubed is 1,000 thirds plus, let's see, excuse me, let's just put that number in again. All right, let's double check ourselves. 10 cubed divided by 3 plus 4 times 10. Okay, and notice I'm going to try to make it look exactly what I'm plugging it in. Minus parentheses 1 cubed divided by 3 plus 4 times 1. And notice parentheses around plug in top minus parentheses around plug in bottom. Yeah, I got 369, but don't forget your units. What would my units be? Because force is measured in pounds, length is measured in feet, this is the famous 369 foot-pounds, which is answer C. But one last little comment on this question. By this time, you are on the calculator section of the exam. And every professor that I know teaching this stuff has sat back, whether you got a T84 or a T89, they have done the old math number 9 integral bit on this one. Once you're allowed to use your calculator on integrals and they got bounds on them, double check your answer. You know, I could have made one careless error with a parenthesis in the wrong spot and screwed this thing all up. So I'm going to just double check myself here. Integral from 1 to 10 of x squared plus 4 dx. Okay, now I'm happy and I know I at least made a 5 on this test. Okay. I can almost pass the class with 5. All right, so there we go. Does that make sense? Look at your next one. This next one is another problem. And I got all my students memorizing all these major formulas from chapters, 6 and 7 and 8, and it's great. And here's your basic formula from chapter 5, and they didn't remember it. What is the average value of the function 8x cubed plus 3 on the interval between -1 and 5? Well, you understand that caught in the headlight look that some students had on this exam with, what's the formula for average value? Because that's what they're questioning. Average value is equal to 1 over b minus a times integral from a to b of f of x dx. While we study old exams to remind ourselves of the formulas we long since forgot. So on this particular problem, a is going to be equal to -1, b equals 5, and they gave me the function here, so when I plug it in, this will be 1 over 5 minus -1 times integral from -1 to 5 of 8x cubed plus 3 dx. Well, this is equal to 1 over 6, minus makes it plus, 1 over 6 times integral from -1 to 5 of 8x cubed plus 3 dx, which is 1 over 6 times integral of 8x cubed. Well, integral of x cubed is x to the 4th over 4. Save some room there. 8 divided by 4 is 2. That'll be 2x to the 4th. Plus integral of 3 with respect to x is just 3x. Evaluated from -1 to 5. Does that make sense? And so, obviously, with the fundamental theorem stuff, I plug in top, but don't forget your 1/6 out front. Plug in top is 2 times 5 to the 4th plus 3 times 5. Minus, plug in bottom 1/6, 2 times -1 to the 4th plus 3 times -1. And at some point, these are nasty numbers, but it's on the calculator section. So I get to crunching in on my calculator, and I get 211. The answer is B. But here's the thing. The reason why I'm showing you this instead of just doing this. Oh, I got the old integral calculator thing here. That's awesome. 1/6 times math number 9, the integral from -1 to 5 of 8x cubed plus 3 dx is, yeah, I'm confirming my answer. We really want you guys to check this stuff on the calculator. The reason why I'm actually writing all this stuff out is, what if they put this problem on the free response section? If you put it on the free response section and you wrote down the formula and you plugged it in, but you actually didn't show on the free response part, show the actual using of calculus. Integrate, plug in top, plug in bottom. You're not going to get all the points. They maybe out of 7 points, they'll give you 1, 2. I mean, you got the formula down, that's worth something, but they're going to tell you on the free response, show your work. So it's a great time for me to just practice showing the work on what we expect if it was a free response question. Does that make sense? But don't kid yourself. Even on a free response question, I'm going to use my calculator. If it's an integral that with bounds, I'm going to use my calculator to double check this thing. But they want to see the work on free response. So don't forget to show them the work. Be over detailed in terms of your work. Take a look at the next problem. A particle is moving along the x-axis at a rate of v of t equals 9t squared plus 4 centimeters per second. How far does the particle travel? So, they want to know distance. How far the travel from 1 to 5. All right. First thing is first. The first thing I would do would be graph this function. V of t equals 9t squared plus 4 over the interval between 1 and 5. And when I graph this thing on my old calculator, this is old t squared, which is a parabola, times 9 stretched out by a factor of 9, shifted up by 4. So between 1 and 5, you're going to get this function to look something like this. That's all I cared about. Because the function is above the x-axis on this particular region between 1 and 5, I know the particle is moving all in the same direction. It's not changing direction. It's when the function is above the x-axis and dips below the x-axis or vice versa that for total distance, I have to separate this stuff. Do you remember? With total distance, if the function is entirely on one side, then it's moving all in that direction. This is positive, so I know it's moving right or up. It's moving along the x-axis, so officially that would be moving right. Does that make sense? But if the function is above the x-axis and then crosses the x-axis and below it, I have to shift, because that means it's moving right, and then it stopped for a second, then it started moving left. Then I have to separate my right, left, or top, bottom regions, because one's moving in a positive direction, one's moving negative direction. You integrate both sections, get an answer, make them absolute value, and then add your answers together. That's the formula for total distance. But because this function's all on one side of the axis, and it's above the x-axis, or in this case t-axis here, the fact is it's above it, it's moving all in one direction. This would be officially to the right. So to figure out your distance, the distance by formula is the integral from a to b of the absolute value of v of t dt, but the function between these intervals is already positive, so I can drop the absolute value mess, and this gives me equal to the integral from 1 to 5 of 9t squared plus 4 dt. Again, showing my work, the integral of 9t squared, 9 is a constant, integral of t squared is t cubed over 3 plus 4t, evaluated from 1 to 5. This cancels there. So plugging it in, this would be 3 times 5 cubed plus 4 times 5 minus 3 times 1 cubed plus 4 times 1. And then it's all about me sticking it on my calculator. And I end up getting 388. What would my units be? Because it's a distance. Centimeters. Again, if this is a word problem on the free response, don't forget your units. That's worth a point every time. Does that make sense? So I got 388, answer C. And of course, I would double check it on my calculator. Does that make sense? Take a look at number 10. Which of the following definite integral gives a volume of the solid attained by rotating the area bounded by the graphs of y equals 2x and y equals x squared? And they were nice on this one because they gave you the picture. I don't know why, because this is a calculator active section for my high school students here, which means that, I could have graphed this thing on my calculator. But once again, I can let you know why. They're trying to cut out mistakes people have made in the past. People have made stuff in the past by graphing or picking out the wrong region because it's above the x-axis or to the x is greater than 0 or something like that that they missed out on. By shading it, they're throwing it in your face. Here's your region. You can clearly identify the bounds and stuff like that. We're showing where the region is. It's not the region up here, it's the region down here type thing here. They're trying to create less careless error. So, here we go. The function on top, well, that's the line. That's got to be f of x equals 2x. The function on bottom is the parabola, so this has got to be the g of x equals x squared. This is my x-axis here, so it's bounded between 0 and 2, and look at my bound, 0 to 2, so I'm pretty happy about this. But now, here's the deal. My function is in terms of what variable? X. What axis did they want me to rotate this region around? The y-axis. And here is my y-axis. The function is in terms of x, and they want me to rotate around the y-axis. What method should you use? This is a shell method problem. Traditional shell method. Functions in terms of x, and you're rotating around the y-axis or something parallel to the y-axis. The shell method formula is volume equals 2 pi times the integral of what I call the point radius times top minus bottom dx from A to B. Functions in terms of x, but this formula allows me to rotate around the y-axis or parallel to the y-axis. So this formula would be volume is equal to 2 pi. The bounds for my region is from 0 to 2 of the point radius. We'll come back and talk about that. But what's the function on top is 2x. The function on bottom minus x squared dx. What would my point radius be? Well, since I'm going to pick an arbitrary point inside my region right here, and it's the distance between that arbitrary point back to the axis of rotation. But when you move away from the y-axis, that is in the x direction, so your point radius is actually x. X minus 0, right minus left stuff. Does that make sense? If I was rotating around the line, like for example, x equals -1, it would have been x minus -1, clean it up, x plus 1. If the axis of rotation was to the right of the region, like 27, it would be 27 minus x. It's always right minus left. Does that make sense? Okay. So, but they didn't actually tell me to integrate it. They want me to look at it. They put the 2 pi back inside here, so it's got to be the dude with 2 pi. So pretty much, I can let you know D and C and D are not it. Which one is this dude? Be careful. It's a minus there, so it's got to be which one? That's what worries me about you guys. I got A. But and I tell my students this also when I teach class. I am very, very good at mathematics. I've done this stuff before. Even when I was in college, when I was at state, I could get the answer. Here was my problem. Everybody makes careless errors. We're all human. You must identify where you make your mistakes at. My mistakes on a multiple choice test is this. I'll get the answer, and I cannot pick him out of a lineup if my life depended on it. How many times have I got the right answer and yet circled the wrong one on this test? I am notorious for doing that, and my students will confirm this from class. But the fact is, know where you make your mistakes at and slow down during that procedure just to make sure you don't make a mistake. Watch your careless errors. Does this make sense? You'll notice on the part 2 on this exam that there were only 10 questions on this one. A grand total of 25 total. And that's pretty standard. The most we've ever given was like 30, 15 on each. But usually it's, I can let you know, they usually don't give you the same number of questions because in case you get your OpScan sheet screwed up, we can find it because one will have 13 things bubbled in, the other one will have like 12 things bubbled in. We can figure out, oh, you screwed up or the professor screwed up or something or other. You'll be bubbling which version it is, but rarely, but it does happen that somebody put something in the wrong pile. So they try not to give the same number of questions. On this particular exam, it was a 15-10 question. 15 with no calculator, 10 with a calculator. But here comes the other big points. Now, in terms of percentages, here's how it goes. 60% of the exam is multiple choice, the 2 parts. That would weigh a little bit heavier. The free response is worth 40% of the exam. It's still huge. You understand that? So, but if you want to think of it this way, it's 30% for part 1, it's 30% for part 2, but it's 40% for part 3. Does that make sense? That's your 60-40 ratio stuff. All right, so here we go. I've got my calculator ready to go, but remember, free response I want to be going over great detail about how I show my answers. Even if I'm going to use the calculator, and I will, but I don't use the calculator to just say, I use TI-81. No, don't put that on the test. We'll take off extra points, that kind of crap. All right, so show us the work in this stuff. All right. And right off the beginning, what are they going to do? Power series. What a surprise there. All right, so here we go. But look at this exam, and then you guys remember your test I just gave you guys. You wonder where I came up with the format for the free response stuff at. Here it is. All right. Even though calculators are allowed, you must show work to receive credit. They already throw it in your face about the calculator thing. We'll let you use your calculator, but if that's all you're using to get the answer, you'll get absolutely no credit for this stuff. And maybe even lose some extra points for making us look at it. So here we go. Taylor series, the Taylor series expansion for 1 over 1 minus x, which honestly is one you're supposed to have memorized. Memorize it, because I can't guarantee they're going to give you this thing. This was awfully nice of them this semester. They gave it to you. But you were supposed to have this stuff memorized. And it kills me, it's a Taylor series centered at 0. What do you call that? All right, just fancy on the words. 1 plus x squared plus x cubed, yada, yada, yada. Okay? Use the Taylor series expansion for 1 over 1 minus x and to find the first, and pay attention to this, first 4 non-zero terms of the expansion of 1 over 1 minus x to the 4th, centered at 0. So they gave me this, and I'm supposed to use it for part A. Again, showing my work. What am I doing here? This is why we love power series. They're easy to manipulate. They gave me 1 over 1 minus x, or at least I have it memorized, and they want 1 over 1 minus x to the 4th. What am I doing? I'm going to replace x with x to the 4th, because that's the difference between the two. So here we go. This will be 1 plus, there's an x, replace it with x to the 4th, plus there's another x, I replace it with x to the 4th, but we're squaring it, plus x to the 4th cubed, plus dot, dot, dot. And again, we're going to write the dot, 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 but how many terms am I showing them? 1, 2, 3, 4 terms. Now, of course, clean it up. Don't give them just this. We'll take off a point for not polishing it up for us. The answer is 1 over 1 minus x to the 4th equals 1 plus x to the 4th plus x to the power to a power to multiply 8 plus x to the 12th plus dot, dot, dot. And there is my answer. And we appreciate it if you circle it too, because our eyes draw to that and we go, oh, that's completely correct, and I can just move on. Because here's how the game is played. And for you guys, okay, you guys are taking the exam on Thursday. On Friday, all the faculty that teach Calculus 2 all get together in a big gripe session and carry our own free responses for each class. And each professor gets to grade 1 problem, and we have to be, this is showing consistency throughout the grading process. So I will show you which problem I actually ended up grading. But so each professor gets to grade 1 problem, okay? And so we have to grade 2,000 problem number 1s, or 2,000 problem number 2s. And we grade everybody's, and then we put everybody's grade together at the end. And if you see the first page of this thing, we record the grade here, and then we add them up, and there's your grade, and we put that into our awesome Excel spreadsheet, and we work on giving you guys the exam results and stuff. Now, a couple of things as we go through this thing. Do not email me. Do not email Desiree. Do not whoever your professors. Do not email. Do not call them. We do not know what your exam is. We don't care. Go away from us. We're trying to grade this stuff. All right. We will probably have all their exam results back. It usually takes, you guys are going to take it on Thursday, Friday and Monday they do all that op scanning stuff. We'll grade this stuff on, so earliest we'll have it on Tuesday, but probably Wednesday when we get all the exam results stuff back. So no emailing it. First, it's illegal to email us about grades because we can't officially talk to you about grades. You actually have to come by and see us about that stuff. So for my class, I will probably be in the office either Wednesday or Thursday, and I'm not sure depending on where my exam results are. But I will be in my office on those 2 days if you want to come by and discuss your grade. But I can at least show you what you did and show you the numbers and stuff like that. But I will be posting them on Moodle. Now for my class, I'm going to put your homework number 4, so I'm going to leave the middle grade book up through the weekend. I won't be touching it. I'll update the web work. That'll be about it. And then all of a sudden, right about Sunday night, I'm going to turn that sucker off because I'm going to obviously download some numbers and things like that into the thing. So the next time you'll see it open, you know the exams are graded. Okay? And I'll put your exam results back. So don't come see me until the exams have been posted on your Moodle site. And I know Desiree's class the exact same way. Don't email. We don't return emails. Don't call me. Don't do anything until I finish grading all the exams and stuff. Okay. Somebody had a question. I had a hand raised.
We figured it out.
Okay, good. Done.
Trying to figure out the power series representation for that.
Power series representation for the numbers. Well, this would be the sum is n goes from 0 to infinity of just x to the n. So this would be the sum of the power series of x to the 4n. Sum is n goes from 0 to infinity of x to the 4n. Which is good, and know how to use the formulas, but on this problem, because they said 4 non-zero terms, I didn't have to do that. But be careful in case they want us to. Sure. Okay. In case they want you to write down the series, this is equal to, if you write down the formula, the sum is n goes from 0 to infinity of x to the n. You plug it in 0, you got 1, x to the first, x squared, x cubed, plus that. That's the pattern. So on this one, when I plug it in, this will be the sum as n goes from 0 to infinity. You're replacing x with x to the 4th. That'll be x to the 4th to the n. So clean it up. Power to a power multiply. So this would have been the sum as n goes from 0 to infinity of x to the 4n. And that's your summation for that formula. All right, so take a look at part B. Use the Taylor series for 1 over 1 minus x to the 4th from part A to evaluate the integral from 0 to x of 1 over 1 minus t to the 4th dt. So again, showing work, because people lost a point on this thing because they were not consistent. My function is right there, 1 over 1 minus t to the 4th. But what's the variable in this thing? It's a t. It's not an x, right? So what you're supposed to do in showing your work and your comprehension understanding here, this would have been the integral from 0 to x of 1 over 1 minus t to the 4th, which would have been 1 plus t to the 4th plus t to the 8th plus t to the 12th plus dot 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 dt, right? So, and I would integrate it. What's the integral of a 1? Because I got bounds, I don't put plus c on it. What's the integral of 1 with respect to t would be t, plus the integral of t to the 4th would be t to the 5th over 5, plus the integral of t to the 8th would be t to the 9th over 9, plus the integral of t to the 12th would be t to the 13th over 13. Since they started out with 4 terms, be consistent, and there they are, being consistent, 4 terms, plus dot dot dot. And so, but then you're supposed to evaluate it from 0 to x. So I plug in top, that'll be x plus x to the 5th over 5, plus x to the 9th over 9, plus x to the 13th over 13, dot, 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 minus, when I plug in 0 into this particular power series, being a Maclaurin series, Taylor series centered at 0, guess what I'm getting? That's beautiful. It's 0. That goes away. So therefore, the integral between 0 and x of 1 over 1 minus t to the 4th dt would actually be equal to x plus x to the 5th over 5 plus x to the 9th over 9 plus x to the 13th over 13, dot, dot, dot. And there is my answer. Now, for those people who want to see the series done, fine. All right. I didn't ask you to do this, but whatever. The integral of the power series for this dude in terms of t would be the sum as n goes from 0 to infinity of t to the 4n dt evaluated from 0 to x. So how do I actually integrate a series? You just integrate it. This will be the sum as n goes from 0 to infinity of t to the 4n plus 1 over 4n plus 1. You with me? No plus c's because I got bounds from 0 to x. And then I'm going to write him down here. Plug in top minus plug in bottom. This becomes a series as n goes from 0 to infinity of x to the 4n plus 1 over 4n plus 1, in case they made you write the series out. Plugging in 0 completely killed it off. Yeah?
Would you lose points if you didn't show, like in the actual
No, we didn't take off points for the dot, dot, dot. We took off 1 point if you didn't put it in terms of x because you didn't follow directions. Because this thing was in terms of x, that meant you weren't paying attention. Okay, but I mean, I think this was like worth, I think we graded this thing, we graded it out of 12 points. So this was worth 4, this was worth 4, this was worth 4. And we made the point totals easy. We grade them all usually out of 12 points. So the total number of points you can get is 60 out of 60 points. And so we would have taken off 1 if you didn't show the beautiful work on integrating the t part. So pay attention to the problem. All right. Part C, use the first 3, they're cutting back on me here, the first 3 non-zero terms of the Taylor series of the integral from 0 to x of 1 over 1 minus t to the 4 tt from part B to approximate this definite integral. All right, so the integral between 0 and 1/2 of 1 over 1 minus t to the 4th dt, we're supposed to use the first 3 terms. So this would be equal to, the first 3 terms are, and this is in terms of t here, 1, 2, 3. So this would have been t plus t to the 5th over 5 plus t to the 9th over 9. First 3 terms of this series, just putting it back in terms of t. But now I'm evaluating it from 0 to 1/2. Again, focusing on their words. 3 non-zero terms, which would be equal to, plug in top, 1/2 plus 1/2 to the 5th over 5 plus 1/2 to the 9th over 9. Minus, when I plug in 0, I get 0. And so when I crunch this thing out, I actually get, well, let's double check it here. What did I get? All right, it'll be 1/2 plus 1/2 to the 5th divided by 5 plus 1/2 to the 9th divided by 9. And I got the number 0.506470139, and I just pretty much circle that. But here's the thing. Round your answer off to the nearest 1, 2, 3, 4, 5th spot. 1, 2, 3, 4, 5 spot right there. So that would be what? 0.50647. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. There we go. All right, but in terms of this problem, I will have to admit to you, if you gave this answer instead of this one, we gave you credit for it. If you actually use 4 terms, you're within the tolerance of it instead of the 3 terms as we threw it in your face, and you use 4 terms, we still gave you credit for it because you're within the tolerance type thing here. But you know, if they say 3 terms, use 3 terms, but if you use more, we didn't take off points for that. What we did take off points for were these beautiful people that did this crap to it. Math number 9, 0 to 1/2 of 1 divided by 1 minus, I use x to the 4th, right, dx. And they gave me this answer. Oh, geez, Dr. Taylor, that looks pretty good. Yeah, but there was no work. They had nothing but the calculator answer off the test. That was worth 4 points. We took off 10. I'm kidding, but still, we wanted to. Just made us mad because actually, more than you know, actually did that thing. They didn't know what to do with the power series because they didn't study chapter 4. Hadn't been there for the last month of class. So I don't know what happened to those guys, but they just knew how to use their TI-8984 calculator and got very excited about. They know they got the right answer, but they thought they'd at least get 1 or 2 points off of it. No, we didn't give them squat for that. It was just basically sad. But there you go. Take a look at the next guy. Find the area. Now this problem, watch this one. This problem messed up a lot of folks. A lot of folks missed this problem. Because this was one of those problems that they just gave you a question and gave you all this space to do it in, and people weren't paying attention. Find the area of the region enclosed by the graphs of f of x equals x cubed minus 2x squared plus 1, and g of x equals 3x plus 1. If you're trying to find an area of a region or volume rotation of a region or doing anything with a region, what's the first thing you should do? Graph it. Let us graph it. Y equals, clear out the old stuff. Actually, somebody asked me this question the other day. Put it back in there. X cubed minus 2x squared plus 1. Make sure I typed in x cubed plus 2x squared plus 1. And g of x is 3x plus 1. I did the old zoom 6 on it. And there is my cubic function. And there is my line 3x plus 1. And I'm going to, for your benefit, before I actually put it up here, I'm going to kind of blow this thing up and focus on the intervals between x's between like -2 and 4, I think is good. Let's see here. Looks, there's my cubic graph, and there's my line. That's good. And you understand that most people are focused on the area captured between the two curves, the big area, but there's a small area too. Do you see the two areas? Hold on, let me help you out here. Autofocus. It's beautiful. Do you see there is another area here? You understand they died on this problem because they only gave half the answer. Because they gave the area the big part, but they lost that little part because they weren't paying attention on their calculator. So here we go. All right, so as I draw this thing up here, I'm doing my darndest. And I need to find some points of intersection here, but let me just show you. This thing looks like this, and it came over here and did this. Okay, actually it came over here and did that. And then it came back down here someplace and did this, and then went back up here. This is not really drawn to scale here. I'm just trying to kind of draw the picture here. And this thing came in here and just kind of grabbed that point there. Bad picture here, but here's the deal. I'm trying to emphasize the fact that there were two areas. You see what I'm trying to do here, but my picture is actually a little off now because this is a little bit higher up there. But that's really kind of emphasize these two parts. But I need my points of intersection. Second, calculate intersection. First curve, yep. Second curve, yep. And I'm going to point at this point over here. I guess it's right about there, and it's the point -1, -2. So this is the point -1, -2. This point right here was pretty obvious, but I'll use my calculator to find it. Point of intersection, first curve, second curve, and I'm going to guess right about there. And I believe it's at the point 0, 1, but let's just double check that. Yep, and that's classic computer, -1.8 e -15. What's that number? 0. 1. So this is the point 0, 1. So it's 1 up here, but this is 0 right there. And then the other point is way over here, and it's up there. I'm going to go second, calculate intersection, first curve, second curve, and I'm going to guess at this point over here. And it is at the point 310. All right, but I clearly have a distinct top bottom to my regions. The problem is there are two regions. There is area 1 and there is area 2. You with me? Go after area 1. What is the formula for calculating area between two curves? Straight up. Top minus bottom dx or right minus left dy. I got tops and bottoms, so I'm using dx on this thing. So this would be the integral from -1 to 0 of the top function, which is the cubic graph, x cubed minus 2x squared plus 1, minus the bottom, which is the line 3x plus 1 dx. Okay? You had to show your work. I mean, I agree. I use my calculator and crunch it out, and you're going to lose probably half the points on this one. If you set up the interval, we did give you something for this, especially if you showed us the part 1, because that's what most people forgot. All right, so, but do show your work. This integral from -1 to 0 of x cubed minus 2x squared plus 1 minus 3x minus 1 dx. This is the integral from -1 to 0. When you combine like terms here, the -1 plus 1 cancels, so you're left with x cubed minus 2x squared minus 3x dx. Okay? So, and area 1 would end up being, when you integrate it, x to the 4th over 4 minus 2x cubed over 3 minus 3x squared, minus 3x squared over 2. Yeah, evaluated from -1 to 0. But now, watch this. Fundamental theorem of calculus. Plug in top minus plug in bottom, but this time the top is 0. And when I plug in 0 on this thing, I'm going to get 0. That's nice. But when I plug in bottom, parentheses, plug in bottom, -1 to the 4th over 4, minus 2 times -1 cubed over 3, minus 3 times -1 squared over 2. Okay? And then at some point, I'm putting on my calculator, and I end up getting 0 minus, this was a -0.58333333, which is equal to a 0.58333333. For you math fraction fans, that's 7/12. It was a very small area. Okay? That's area 1. Now you got to go and calculate area 2. But area 2, here's the deal. Because that flip-flop, the top and bottom switched. So now this would be the integral of what's on top, which is 3x plus 1, minus what's on bottom, which is x cubed minus 2x squared plus 1 dx from 0 to 3. So again, setting up the integral, that was the big points, and then there's a couple extra points. It's a 12-point problem, a couple extra points of showing the details of the integration stuff here. So the next thing I would do is obviously clean this up. The integral from 0 to 3 of 3x plus 1 minus x cubed plus 2x squared minus 1, and the plus 1 minus 1 is canceled. Don't forget the dx. We did take off a point. If you flopped off that dx, you got an integral, you got to have a d something or other in the end. Setting you guys up for calculus 3 later on. All right, so this turns into area 2 is equal to the integral from 0 to 3 of -x cubed plus 2x squared plus 3x dx. When you integrate it, this is -x to the 4th over 4 plus 2x cubed over 3 plus 3x squared over 2 evaluated from 0 to 3. Fundamental theorem of calculus, plug in top minus plug in bottom. This will be -3 to the 4th over 4 plus 2 times 3 cubed over 3 plus 3 times 3 squared over 2. Minus, when I plug in 0 was nice because I got 0. And when I put that on the old, at this point I really did use calculator, which was fine. Once you showed me what you were doing at this point, it's calculator, you get 11.25 or 45/4. But now, here was the big deal. Again, we broke this up into 6 points and 6 points, and you see a lot of people lost 6 points. We did give you credit for the other half the area. But here comes the total area captured between these two functions is what? You would take the 0.583333 plus 11.25 for you decimal fans, or which would be equal to 7/12 plus 45/4, and you end up getting your answer of 11.833333, which is equal to 71/6. We took either one, but don't forget it was units squared because you calculated the area. Does that make sense, though? And you can see a lot of people lost 6 points on this one because they didn't see, quote, the other area that was captured. Does that make sense? All right, move on next one. Yep. The committee did listen to us about giving straight problems and just giving them to you without the parts A, B, C, D, C stuff here. And here's another one. Whole big sheet of paper here for you to calculate this. Find the interval of convergence of a power series. Right off your last test. And man, that was awfully nice because they tell you don't forget to check your endpoints here. That should be pretty obvious. But here's the deal. To find the interval and or radius of convergence of a power series, what am I going to use? Ratio test. So here's my series. This is the sum as n goes from 0 to infinity of x to the n over 5 to the n times n squared plus 4. Okay? Ratio test. So with the ratio test, I'm going to end up taking the limit as n approaches infinity of the absolute value of an plus 1 over an. This will be equal to the limit as n approaches infinity of the absolute value of an plus 1 would be x to the n plus 1 over 5 to the n plus 1 times n plus 1 squared plus 4 over x to the n over 5 to the n times n squared plus 4. Now, I taught my students about this idea of fraction divided by fraction, invert, multiply, and spread it out so you can combine like terms quickly. This saves you a lot of algebra work here when you clean it up quickly with this. So I'll take my numerator, absolute value here. This will be x to the n plus 1. This will be 5 to the n plus 1. And this would be, actually, if I fold this thing out, which I'm going to do, I'm going to get n squared plus 2n plus 1 plus 4 is plus 5. All I did was fold this part out just to save myself a little algebra, because that n part's the part I'm going to be taking my limit on. When I invert and multiply, the x to the n will show up on bottom, but the 5 to the n shows up on top with this n squared plus 4. And includes your absolute value. So there's a lot of algebra from here to here, but it's this idea of when you divide by a fraction, invert, multiply, and all I'm doing is juggling this thing so I can see the like terms together, because you know with the ratio test, with the powers of n and factorials, you're going to see lots of stuff cancel. What cancels here? Well, let's see here. I've got x to the n plus 1 over x to the n. Well, x to the n plus 1 is the same thing as x times x to the n. I just pulled off the part I didn't need, and the x to the n's cancel. 5 to the n's and 5 to the n plus 1s. 5 to the n plus 1 is the same thing as 5 times 5 to the n, and the 5 to the n's cancel. So I'm left with an x on top and a 5 on the bottom. That's just my powers canceling. So this officially is equal to the limit as n approaches infinity of absolute value of x over 5, but in the numerator times x squared plus 4 over, folded out and cleaned it up, n squared plus 4 over n squared plus 2n plus 5. Now take your limit as n approaches infinity. Now officially, if I plug this thing in, I'm going to get infinity over infinity. So I could use L'Hopital's rule, which would be equal to the limit as n approaches infinity of 2n over 2n plus 2. But then you're going to have to do L'Hopital rule again, which will be derivative of the top is 2 over derivative of the bottom, which is 2, which basically the thing goes to 1. If you did that, that's fine. If you marked through this thing and went, well, since the degree of the top equals degree of the bottom, you get 1, we were excited that you recognized that fact and gave you full credit for it. You didn't. This part right here is actually calculus 1, and you could actually look at the answer. If you just marked it through, because degree of the top does equal degree of the bottom, answer is 1. We were real excited. But officially, if I wanted to prove it to you, I ended up using L'Hopital's rule on it. Does that make sense? Either way, we're real happy. You should get this part as 1, making this thing equal to absolute value of x over 5. Now, when does the ratio test converge? Because we want this interval convergence. It's got to be less than 1. So solving this part, that means that negative 1 is less than x over 5, which is less than 1. Which means when you multiply by 5 on all sides, I get negative 5 is less than x, which is less than 5. This, as I tell my students, is almost my interval of convergence. What's the last thing I got to do when I'm doing the ratio test and finding interval of convergence? Test the endpoints. So here we go. My endpoints are x equals negative 5 and x equals 5. Now, before I even start this process of plugging in negative 5 and 5 into my power series here, I'm going to get a series for one of them and then the other, and they're going to be almost identical except for one thing. What's the pattern here? One's going to be alternating, which means I'm going to use the alternating series test on it, and the other one's not, and I'll have to use another test. Okay, and there's more than one test you can use on this stuff. Sometimes it just shows up as a harmonic, and that's awesome, and you know what it is, but sometimes you have to use a test, and remember, there's more than one test you can use. Here we go. Plug in -5. This turns my series, plugging it in right in here, turns my series into sum as n goes from 0 to infinity of -5 to the n over 5 to the n times n squared plus 4. This turns into the sum as n goes from 0 to infinity of -1 to the n times 5 to the n over 5 to the n times n squared plus 4. And you notice the 5 to the n's cancel. So this is equal to the sum as n goes from 0 to infinity of -1 to the n over n squared plus 4. So far, so good? What kind of series is this dude? Because what I did with that -5, I pulled off the negative. And remember, -5 is -1 times 5, and times, I get to distribute powers. Only through strict multiplication division, I distribute powers. It makes an alternating series, so I'm going to use the alternating series test. My Bn part is the part without the alternation, is 1 over n squared plus 4. And so remember, with the alternating series test, we've got to test two things. The first thing we've got to test is write down some terms. N equals 1, n equals 2, n equals 3. This thing started at, n equals 0, n equals 1, n equals 2. It did start with n equals 0. If you go back up here, you always start with the term. N does equal 0 at the beginning. That's fine. So when I plug in n equals 0 here, I'm going to get what? Let's see here, 1/4. When I plug in 1, I'm going to get 1/5. When I plug in 2, 2 squared is 4, I'm going to get 1/8. But my terms are going down. And the second thing is the limit as n approaches infinity of the 1 over n squared plus 4. Infinity squared is infinity, plus 4 is bigger infinity. And 1 over infinity is 0. So my terms went down and my limit went to 0. What does that mean? Convergent by the alternating series test. Hence, do I want -5 in my interval of convergence? Yes, we will note that by putting a big old equal to in there. So now my interval of convergence is between -5 is less than or equal to x, which is less than 5. Keep on going. Now we got to check the other endpoint, 5. Plugging 5 into this thing, and I'll draw a little line here so I don't want you guys getting confused. Plugging in 5, but here's the thing. You should already know what this series looks like. It's that series with a 1 to the n, which is 1. 1 over n squared plus 4. So, but I got to show it to you because I got to show my work. The sum as n goes from 0 to infinity of plugging in 5 into this series right here. Plugging x equals 5. That'll be 5 to the n over 5 to the n times n squared plus 4. And you'll notice the 5 to the n's cancel. And what a surprise, I get the sum as n goes from 0 to infinity of 1 over n squared plus 4. But now you got to test this thing. What test would you use on this thing? Comparison. And so, all right, which comparison test would you use? You want to use direct or the limit? All right, go for it. Fine. We're going to use the DCT, the direct comparison test. I'm going to take this guy, the sum as n goes from 0 to infinity of 1 over n squared plus 4. All right, but you got a little bit of a problem with this direct comparison test, but that's okay. It will be less than or equal to what? Well, you want to compare it to this guy, the sum of 1 over n squared. The problem is, because you add 4 to the denominator, makes the denominator bigger, makes the overall fraction smaller, which is fine. But the problem is you can't really start at 0 because 1 over 0 doesn't exist, so it's kind of 1 to infinity. But it's an infinite series, so it's a little bit of a shifting here, but these guys are comparable. Okay? But you actually had to put this guy. Because what's this guy's name? P series. Tell me about it. P equals what? 2, which is bigger than 1, which means it does what? Converge. So the dude on top is convergent. Therefore, The dude on the bottom is converging by the direct comparison test. But you did have to do a little bit of a shift on this one because of n equals 0. I couldn't do 0 here, but I can do 1. But because I'm adding them up to infinity, you can do an offsetting shift and you're still comparable. Okay? So you got the right guy to compare to. But here's the other thing, and this was to make this one tough. You guys told me to use the direct comparison test, but I could have used several tests. Can you tell me all the tests I could have used? We could have used, like I said, direct comparison test, or what's another one? Limit comparison test. Wait a minute. Would you use a ratio test on this thing? Never. Only powers of n or factorial would you ever use ratio test. But what other test could you use? Outstanding. This is calculus 2. Could you integrate this? And if you integrate it, what would you get? Arctangent. It's that 1 over x squared plus 4 looking thing. This is an arctangent style. So you could have used the integral test. Is there any other test? The limit comparison test, the direct comparison test, the integral test. Which one? Divergence test. This thing converges. That's one of those things. Be careful of that. I put that on my test. See if anybody would fall into that loop. Converges by the divergence test. That's about as stupid as it gets. But some people fell into it. So, but whatever. But like I said, there were 3 of them. The other one was the direct comparison test. So we were optional on this one. But here's my point. Do you want this point in your interval of convergence? Did it converge? Yes, it did. So you wanted to put this guy right here. So to answer the question, there was a lot of work on this one we were looking for, but at the end of the day, this was my answer. Also, I would accept bracket -5 to +5 in interval notation. Does that make sense? Question? Yeah. Well, first off, you have to tell us what you're comparing it to and what you're comparing it to does. As I mentioned here, we are comparing it to, the sum is n goes from 1 to infinity 1 over n squared, which is a p series. P is bigger than 1, so it converges. So I know I'm comparing it to a known convergent, in this case p series, and then I'm checking that inequality. And you don't have to describe this, it's implied, but when adding 4 to the denominator makes the denominator bigger, makes my overall fraction smaller, so everything sets up when you're doing the direct comparison test. Yes. You have to tell me what you're comparing it to and what it does and why. But you're comparing it to something that you know. P series, geometric series, harmonic series, something like that. All right. There's typically 5 problems with this stuff. Here's problem number 4. Again, looking at this problem and thinking about formulas. This problem is they're going to give you a region, and this time they're going to make you graph this region. And pay attention, where students screwed this stuff up was they didn't pay attention to the region. They're going to ask you 1 about area, 2 about the x-coordinate of the centroid, and the y-coordinate of the centroid. So we got to go back and memorize our center of mass formulas. All right. First thing you need to do is graph. Consider a region in the first quadrant bounded by the curve on the right, and by the graph of y equals 4 minus x squared, and on the left by the y-axis, and below by the x-axis. So you've got bounded above and on the right by the graph of, and here we go. What does this thing look like? 4 minus x squared. I don't need a calculator for this, but maybe you do, who knows. 4 minus x squared. Well, x squared is a parabola. Negative in front of it's upside down, shifted up 4 units. So this thing is going to be here, up here at 4. It's an upside down parabola. So it looks like this. And clearly it goes through -2 and +2, because -2 squared is 4 and +2 squared is 4, and 4 minus 4 is 0. So there it is. But here's the deal. This is where people screwed it up. They left it like this, but they didn't finish reading it. Bounded above and on the right by this graph, on the left by the y-axis. So the y-axis is on the left. The x-axis is bounded below Now, if this is on the left, you're actually talking about just that region. And you understand what I'm saying here. People weren't paying attention to the region itself. You have to understand the way they're going to put it in there. Sometimes they put x is greater than 0, y is greater than or equal to 0, something like that. Or they'll try to describe it to you in words. But that's the region. How do I find the area of this guy? So area is equal to the integral from a to b of top minus bottom dx, because my function's in terms of x. This is the graph of y equals 4 minus x squared. So this is very straightforward. This will be the integral from 0 to 2, because we only care about the stuff in the first quadrant. And could have said that word, that would have been great. But they didn't. They said to the right of and to above, that type of thing. Integral from 0 to 2 of, the top is 4 minus x squared. Officially, the bottom was 0 because it's bounded by the x-axis, which is y equals 0, dx. So my area is equal to the integral from 0 to 4 of 4 minus x squared dx, which is equal to 4x. 0 to 2, thank you. 0 to 2 of 4 minus x squared, which is 4x minus x cubed over 3, evaluated from 0 to 2. Fundamental theorem, plug in top, 4 times 2 minus 2 cubed over 3, minus plug in bottom, which is 0. 4 times 2 is 8, minus 2 cubed is 8 thirds, and so this is just a fancy, it is 8 minus 8 thirds, which is 5 1/3 for your fraction over 16 thirds. 16 thirds units squared. That is my area. If you wrote them the decimals, which was 5.333333333 units squared, yeah, we give you full credit for that too. Does that make sense? Does that leave any questions, complaints, comments on that? But now let's go through what you guys remember about the x-coordinate for the center of mass. Here we go. Now I may need some space over here because I'm going to write down the formulas you're supposed to have memorized. Mass, by formula, is density, and our symbol for density was rho times area. We had the formula in rho times integral of top minus bottom dx, or officially right minus left dy. But it's rho density times area. Rho was our symbol for density. The moment about the x-axis, it was the tendency to rotate around the x-axis, came from the disk washer method. That would be rho over 2 times integral from a to b of top function squared minus bottom function squared dx. And the moment about the y was rho times integral from a to b of x times top minus bottom dx. These were the three formulas you were supposed to have memorized for the center of mass stuff. And they came from the disk washer and the shell method of problems, if you remember the awesome lectures that I gave. Okay? Does that make sense? Now, and rho stands for density, but here's the thing. They did one semester, they messed people up by putting a function in terms of y. If I do it in terms of y, the moment about the x actually ends up being rho times y times right minus left dy. You have to kind of switch these two formulas around because this is based upon dx. So, the functions in terms of x, the moment is the tendency to weeble wobble around the x-axis type thing here. So that's why it follows the disk washer method. But if I was going around the y, if the function's in terms of y, I'm going around the x, I'd end up having to use the shell method for that one. So be careful on having to flip-flop these formulas in case they give it in terms of y. But now, and also the last thing was this, to get the center of mass, the x-coordinate for the center of mass, you actually take the moment about the y and divide it by the mass. To get the y-coordinate for the center of mass, you take the moment about the x and divide it by the mass. You keep that in mind, that you got to take the moment about the y and divide it by the mass gives you the x-coordinate. The moment about the x divided by the mass gives you the y-coordinate. So here we go. In this particular problem, this is what we're trying to find, the x-coordinate. So there it is. First thing I'm going to do is I'm going to find the mass. Mass is equal to rho times the area. See previous problem for area. So my mass would be equal to what? 16/3 rho. Notice the answer up there. Does that make sense? And I'm going to need that part for both these two forms. But now to get the x coordinate here, I need the moment about the y. The moment about the y would be rho times integral from 0 to 2 of x times top function, which is 4 minus x squared, minus bottom function, which is 0, dx. Just to show you, top minus bottom dx. Now you want to clean this up, because did they say on this problem, use your calculator to integrate? No, they didn't. So if you want full credit for this thing, what you're going to have to do for them? These are simple problems. They're not overly difficult. If they were, they probably would have put in there, use your calculator to integrate. They've been known to do that if they were nasty. This was not nasty. This was nice. So the moment about the y would be rho times integral from 0 to 2 of 4x minus x cubed dx. Does that make sense? And now this would be the moment about the y would be rho times, the integral of 4x would actually be 2x squared. It's 4x squared over 2, but I'm just cleaning it up in my head to save some space there. Minus integral of x cubed is x to the 4th over 4. Evaluated from 0 to 2. So this would be rho times 2 squared minus 2 to the 4th over 4. Minus rho times, when I plug in 0, I'm getting 0. So let's see here. This would be rho times 2 squared is 4 times 2 is 8 minus 2 to the 4th. That's 16. 16 divided by 4 is 4, which is equal to 4 rho. My moment about the y, what we were looking for is 4 rho. Now back up here. They wanted to know what the x coordinate is. This is why you circle your answer, because I wrote down the formulas. That's for your benefit. And because I probably wouldn't have done that on my test. I would have just wrote down the formula that I needed, but whatever. But this is for you guys as you study. But so all this was to come up with this thing over here. And so I'm going to go back up here and get my x coordinate. The x coordinate is the moment about the y, which was 4 rho, divided by the mass, which was 16/3 rho. What do you notice about the rows? They'll cancel. And I got 4 divided by parentheses 16 divided by 3. And what do I end up getting there? 3/4. The x coordinate is 3/4. Also accepted for you decimal fans, 0.75. It's a coordinate, so there it is. And I'm circling it so the professor can find it. Yeah?
Usually when we're looking for our point radius, we use the axis of rotation to find that. So what do you use when you do that?
Okay, so if it's the moment about the, for the y, the moment about the y is you're using the y-axis, because that is your axis of rotation. So if you're talking about your region here, your point radius would be an arbitrary point inside your region back to the axis of rotation. But when the axis of rotation is the y-axis, your point radius is x. That's why the formula has x in it. Does that make sense? Okay. Now, the last part on this one is find the y-coordinate. Well, I've already got the mass, so now I've got to find the moment about the x. The moment about the x would be my formula rho over 2 times integral from a to b of the top function squared minus the bottom function squared dx. So this would be moment about the x would be rho over 2 times integral from 0 to 2 of the top function, and my top function is 4 minus x squared minus the bottom function, which is 0 squared dx. Again, identifying my region. The top function is 4 minus x squared. The bottom part is just y equals 0. So this part goes away. But if I'm going to show my integral, I'm going to have to clean this up by pulling it out. The moment about the x is rho over 2 times integral from 0 to 4 of 16 times minus 8x squared plus x to the 4th. Just to let you guys know, I did it in my head, but I did a classic full method, first outer, inner, last, and combined the outer, inner stuff. Let's see here. 2. I keep writing that 4 thing down because that 4 is there. But see, from 0 to 2, you're right, but I'm pulling it out. well, 4 times 4 is 16. 4 times negative x squared is negative 4x squared. Another negative x squared times 4 is another negative 4x squared. That's where my negative 8x squared comes from. And then last, x squared times x squared is x to the 4th. Integrate each term. This gives me my moment about the x is rho over 2 times 16x minus 8x cubed over 3 plus x to the 5th over 5. Evaluated from 0 to 2. So this would be rho over 2 times 16 times 2 minus 8 times 2 cubed over 3 plus 2 to the 5th over 5 minus, when I plug in 0, I pretty much get 0. Does that make sense? So now, but be careful, there's a rho over 2 out front. It's rho over 2 times 16 times 2, double check me on this, minus 8 times 2 cubed, which is 8 divided by 3, plus 2 to the 5th, which is 32 divided by 5. And when I put it all together, I end up getting an awesome fraction of 256/15. It really did. I just put it on my calculator. Let you guys see it. All right. So there it is. But then I got to do divided by 2, which is 128 over 15. So it's 128 rho over 15 when you put this stuff together. So now, to get your y coordinate, this would be equal to the moment about the x, which is 128 rho over 15, divided by the mass, which is 16 over 3 rho. Okay, using my formula up here to plug it in. So, and I would divide that number by parentheses. You'll notice the rows end up canceling. 16/3. Double check me on this, but I got 1.6 for you decimal fans, and for you fraction fans out there, I got 8/5. And this is what they wanted to see. And then I kind of double check myself to make sure I'm in the thing. So it's here's 1, so it's 0.75. That's up to 4, and it's 1.6. Yep, that's pretty much my center of mass right there in the middle. Great stuff to study for the old exam. Now look at part number 3. And you should not be real surprised by this. Question number 5, part number 3 here is the last 3 questions. They want you to integrate it. Practicing your integral skills. This first problem here, what technique of integration would you use to integrate this thing? Use substitution. What would you let u equal to? 3x squared plus 1. Then I would do du. The derivative of this thing would be what? 6x dx. Move the constant to the other side under u substitution. 160u equals x dx. And I pause, hesitate, and look to see if there's an x dx in my problem. With u substitution, whatever you let u equal to, up to a constant, du's got to be in the problem, which it is. So when I substitute, now 24 is a constant, it'll just stay there. This is cosine, this part was u, but that x dx gets replaced with a 1/6 du. I mean, I'm literally doing substitution in this thing, and this is what we want to see. So what is 24 divided by 6? 4. It's a constant, goes out front, so this is 4 times integral of the cosine of u du. This is equal to 4 times, what is the integral of cosine? Sine u, no bounds, plus c. And the last thing you do to back u substitution is back substitute. That'll be 4 times the sine of 3x squared plus 1 plus c. Let me stop here as you guys are copying and reminding yourself of this stuff. We had not a lot. Out of about, how many students we had? 1,000 plus 1,200 students. We had probably about 20 students sit there and had this answer with no work. You know what that is? TI-89. Yeah, I recognize across the room. Yeah, perfect, but with no work. How many points are they going to get? Nothing. Questioned. Does that make sense? Okay. Look at the next one. Next one, This one was an interesting problem which caused some people some fits because it's an integration by parts twice problem. All right. And you had to show your work. Now, you can use the table method if you want to, but if you showed your work, this is kind of what we wanted to do. Substitution doesn't work on this thing, and it's a kind of a classic problem that you should recognize, but because it's an x squared out in front, it'll take me two derivatives to get rid of that thing. That's why it's an integration by parts twice. So I'm going to use my integration by parts formula. Integral of u dv equals uv minus integral of v du. So a big part of this was problem recognition. On this part, I would let u equal to x squared, but and they try to make you work on this one. That makes dv equal to e to the 5x plus 1 dx. That makes du equal to 2x dx, because you have to do is take derivative. This is integration by parts. We don't move constants. But then you had to integrate the v. So if I had to get dv, I have to actually integrate e to the 5x plus 1 dx. Well, this was a classic just u substitution. U equals 5x plus 1. That means du equals 5 dx, which means 1/5 du equals dx. So this problem turns into 1/5 the integral of e to the u du, which is equal to 1/5 e to the u. No plus c's on this stuff because it's the u v part. That'll be 1/5 e to the 5x plus 1. That's what you get. And you kind of almost can do that K rule on this thing and be able to do it in your head to be able to get this. So v would be equal to 1/5 e to the 5x plus 1. But all you have to do is do that thing once, because now you got it and you're going to see this thing start working out. So here we go. So this problem now turns into, I'm going to write a big old equal to right here, u times v, which is x squared times 1/5 e to the 5x plus 1, minus integral of v, which is 1/5 e to the 5x plus 1, du, which is 2x dx. Now I'm going to clean this guy up. So this thing is equal to x squared over 5 e to the 5x plus 1, minus, pulling all my constants out, that would be 2/5, integral of x e to the 5x plus 1 dx. So now, being I pulled the constant out front, you could have left it inside and it would change it slightly, but your final answer will not change. Now I'm going to integrate this guy, which means I'm going to integrate this guy using integration by parts. Integral of u dv equals uv minus integral of v du. U would now, I left the constant out front, so remember the constant's there. I'm just integrating the x e to the 5x plus 1. I would let u equal to x. That makes du equal to dx. That makes dv equal to e to the 5x plus 1 dx, which makes v equal to the answer I got before, which was 1/5 e to the 5x plus 1. So, plugging this part into my uv minus integral of v du problem, this would be equal to x times 1/5 e to the 5x plus 1 minus integral of 1/5 e to the 5x plus 1 dx. Cleaning this guy up, this is x over 5 e to the 5x plus 1 minus 1/5 times integral e to the 5x plus 1 dx. But guess what? You've integrated him before. I wish they would have given more space on this one because it's an integration by parts twice deal. But we've integrated this guy. This is another 1/5 e to the 5x plus 1. So once you get that first initial integral, it just keeps popping in here. So this thing cleans up to be x over 5 e to the 5x plus 1 minus, what's 1/5 times 1/5? 1/25 e to the 5x plus 1. So I'm going to take this answer right here and go back and plug him in here. Okay? And then I'm going to clean up my final answer. And remember, I'm going to circle it bold so I can see it. So this would be x squared over 5 e to the 5x plus 1 minus 2/5 times this answer, x over 5 e to the 5x plus 1 minus 1 over 25 e to the 5x plus 1. Okay, I just substituted that guy back in here. And now I'm going to distribute. This would be equal to x squared over 5 e to the 5x plus 1. Now when I multiply, this will be minus 2x over 25 e to the 5x plus 1 plus 2 over, what's 5 times 25? 125 e to the 5x plus 1. The last thing, does this thing have any bounds on it? And I put a big old plus c, and there is my glorious answer that they were looking for. And you're right, it's an integration by parts twice problem, but this is what we wanted to see. Again, for those folks that have the T89, you kind of get this thing, except the T89 is going to factor out the 125 and e to the 5x plus 1 and get you some crappy polynomial. And we recognize that answer from across the room, and we gave you guys absolutely no credit whatsoever because you were supposed to show your work on this thing. So we wanted to see the work and integration by parts twice on this thing. And if you lost a constant or something, we did give partial credit, but the fact is we didn't give you any credit without showing large sums of work on this thing. Does that make sense? And then last but not least, this problem here. If you notice on this particular exam, they hit you hard on this one. What formula is this one? It's actually the arctangent formula. You're supposed to recognize that, but let's just write it down in case you forgot it again. The integral of 1 over u squared plus a squared du is equal to 1 over a arctangent of u over a plus c. That is my arctangent formula. But now on this one, you're supposed to recognize that fact with the x to the 4th plus 1, but that's a 2x on top. And a lot of people are trying to do partial fractions on it. The denominator doesn't factor, so it's not a partial fraction problem. I saw some weird answers on this one, but here's the thing. You're supposed to show your work recognizing its arctangent with the appropriate substitution. U squared would be x to the 4th. That would make u equal to what? X squared. But remember, when you're applying a formula, you got to do u substitution. And so you got to do du. What's the derivative of x squared? 2x dx. And see, that's actually in the problem. So I'm not going to move the constant to the side. I could if you want me to, but the 2's end up in the half would end up canceling. That's actually what's in the problem, 2x dx. So when I actually do u substitution, and in this problem, the a squared was equal to 1, making a equal to 1. So when I actually substitute in this thing, this becomes the integral of u squared plus 1 is the a squared, but the 2x dx is actually just 1 du. When you substitute. And that is the formula, 1 over a arctangent of u over a plus c. And then all I had to do is back substitute. What was a equal to? 1. So it's 1 over 1 arctangent of u, but u is x squared over a, which is 1, plus c. So the final answer we were actually looking for was just the arctangent of x squared plus c. But again, no work means no credit. Does that make sense? Now, before you guys leave, I wanted to look at least do a couple of problems just to practice. Because on this test, the big complaint about this test was this. There were no pumping problems on this test. There will be a pumping problem on your test. So I decided to do a quick pumping problem on this thing. So I'm going to go back and let's see here. I pulled out this guy here. And you also notice one other thing. There were no spring problems on this test. I thought we would do one pumping problem and one spring problem in the last few minutes I got left here. All right? So the pumping problem here is, I don't know, which one would you guys like to do? You want to do it circular or box-shaped? Circular one? All right. How about this kind of problem? Let's just practice it. All right, there's when your cross sections would be circular. This kind of problem here, the cross sections would be what? When you actually put your coordinate axis and do your slice, the slice would be box shaped. Make sure you can do both and visualize this stuff. So, let's do the famous cone. Integrate the cone. All right. So, on this particular problem, it has a height of 12 meters. It has a radius of 4 meters. And you want to pump it to 3 meters above the top of the tank. The first thing you got to do on any kind of tank problem is draw a coordinate axis and do the cross-sectional cut. So on this thing right here, here's my cross-section right here. On this type of tank, being a cone, I'm going to put the coordinate axis at the bottom. Here's X. I'm going to do this guy here. And draw my picture in here. And now, how tall was this thing? 12 meters. What was my radius on this thing? 4. So this guy would be 4 over here. Here's your y-axis, and you want to integrate, you want to lift all the water out of this tank to 3 meters above the top of the tank. That makes it up here at what? 15. This is your target. So you have to put the coordinate axis on this guy. Imperative. The second thing is this. You got to know the formula for work, for pumping problems. Work was equal to the sum of your delta force times the distance that you have to pump. Where delta force was equal to what I call water weight times the delta volume slice. All right? Now, there are 2 water weights you're supposed to memorize. In the metric system, it is what? 9,800. It is 9.8 gravity times the density of water, which is 1,000 kilograms per meter cubed. That's where your 9,800 newtons per meter cubed comes from. If they give you something like gasoline or something like that, they're going to tell you the density in the metric system, and you will multiply it times 9.8 gravity to get the density of it. Okay? But when it's water, which is 9 times out of 10 what we deal with, if it is water, you just pretty much use 9,800. And they will say in the problem, the density of water is 1,000 kilograms per meter cubed. If it is the English standard problem, what does water weigh? 62.5 pounds per foot cubed, and you just chunk that number in for water weight. But pay attention. What kind of system we got here? Metric system. And I'm thinking it'll probably give you a metric problem so they can state the density of whatever's in it, and you have to multiply it times 9.8. But since this was the metric problem, what's my water weight? 9,800. Officially newtons per meter cubed, metric system. Now I got to do the delta volume slice. Your delta volume slice, you come over here on an arbitrary spot inside your tank and make a horizontal slice. And I want to remind you, when you make a horizontal slice, there's only 2 slices you can get. It's either going to be box-shaped or it's going to be disc-shaped. There's only 2. Okay? Because this is circular, again, going around the y-axis, it's going to be circular shaped. If I do something like this problem and put my coordinate axis on there and make my slice, it's going to be a rectangular little box, length times width times height. Pay attention to the type of tank you got. All right? So my delta volume here, if I'll take this little part and pull it out, it looks like a little disc. It is delta y tall, and it has a particular radius. And because it's a disc, the delta volume is, because it's a disc, is pi r squared h. That's the formula for a disc, a little circle. The formula for a box-shaped one is length times width times height. Okay? Now, here's the deal. This thing's on a side, on a slant. If it's vertical, completely vertical, your x is whatever number it is. But because this thing is on a slant, depending on whether I put the slice at the bottom or the top, your radius is changing. What is the radius of this particular problem at this particular point? You're moving away from the y-axis. What is it? X. It's going to be x. So my radius is equal to x. Okay? What's the height on this thing is delta y. So my delta volume would be pi times x squared times delta y. Pi x squared delta y. So my delta force is 9,800 pi x squared delta y. If this was box-shaped, I would have to have the entire width of this thing. If this side is x, and if it's on a slant, if this side is x, what's this side over here going to be? X, so the total distance would be 2x. 2x times the length times the height, which is delta y. Does that make sense? Go back and review this if you don't know. All right, so now, there's my delta force. So work is equal to the sum of delta force, which is 9,800 pi, times x squared delta y, times the distance I have to pump. This slice you made was at an arbitrary y level. Remember, work is all about lift. So I've got to lift this thing to my target. I'm supposed to lift this thing to 3 meters above the top of the tank. Based upon my coordinate axis, where's my target? 15. This is an arbitrary y level, so how far do I have to lift it? 15 minus y, top minus bottom. And remember, this is an arbitrary variable y level. So now when you convert this thing over, this converting into integral calculus, constants, 9,800 pi goes out front. This is the integral of x squared times 15 minus y, and your delta y turns into a dy. And you've got a problem. You know what your problem is? I got a middle of x squared in the middle of my dy. And you're going to get this when your tank has a slant on it. If it's completely vertical, this will be constant. But if it's on a slant, you've got to come up with the relation between x and y, which is the equation of the edge of the tank. You're going through, if you plot these points, the origin is at the bottom. This point up here, the edge of the tank, the relationship between x and y, is at the point 412. Does that make sense? And so this is a line. So I got to come up with the equation of that line. So the first thing I got to do is I got to find the slope of this guy. And we expect you guys to be able to do all this stuff. This is your life. You should get used to it. So I got to get this y here. All right? So then we got to get the slope, which is change in y over the change in x, which will be 12 minus 0 over 4 minus 0, which is 12 divided by 4, which equals 3. And then to get the line, you've got to use the point slope form. Y minus y1 equals m times x minus x1. And I like using the point 0, 0 because that's the easiest thing to plug in. So I get y minus 0 equals my slope of 3 times x minus 0, or my line is y equals 3x. That is the equation for the edge of the tank. Does that make sense? But I need to plug this guy in here for in terms of x because I'm trying to integrate it. I got to solve for x in terms of y because I got to integrate with respect to y. So if y equals 3x, what does that make x equal to? Y divided by 3. I'm going to plug it in here and be careful. So work equals 9,800 pi times integral of y divided by 3 squared times 15 minus y dy. Okay? Now, here we go. What are my bounds? What are my bounds on this thing? Well, I'm integrating with respect to y, so I want y bounds. Remember, you only integrate where the water is that you want to remove. Where is the water we're removing? This thing is full of water, so I want to remove all the water. Where's the water at? Between where? 0 and 12. You're lifting it up to 15, but your water originally is between 0 and 12. If I said, just in reference terminology here, you want to integrate, you want to lift out just half the water, which half would you lift out if it's in a tank? The top half you would integrate from 6 to 12. Does that make sense? You integrate over what gets removed when you're pumping it. All right, but I want to remove all the water there. Now, if I had to show my work on this thing, this is one that is doable. They would also say set up the integral, then I would be done. If they say you can use your calculator to integrate, then awesome, use your calculator. Even if they don't say use your calculator to integrate, it's in the calculator section. You should use your calculator to integrate so you can make sure you didn't screw it up. Does that make sense? All right, but I can do this one by hand. So 9,800 pi is a constant, but I can clean this guy up. So work equals 9,800 pi times integral from 0 to 12. But you got to square y over 3. That makes it y squared over 9 times 15 minus y dy. That 9's a constant. I'm going to pull him out front. So this would be work equals 9,800 pi over 9 times integral from 0 to 12 of, and now I'm going to distribute my y squared. That'll be 15y squared minus y cubed dy. I can integrate this stuff by hand if you pay me enough. Work is equal to 9800 pi over 9 times the integral of 15y squared is what? 5y cubed. It's y cubed over 3, but 3 goes into 15 5 times. I cleaned it up in my head. Minus y to the 4th over 4, evaluated from 0 to 12. And then you plug in top 9800 pi over 9 times 5 times 12 cubed minus 12 to the 4th over 4 minus, when I plug in 0, I pretty much get 0 there. And then I get my answer, plugging it over here. Work is equal to, and typing it in, I typically leave, on this circle stuff, leave the pi off, 9800 divided by 9, put parentheses around your fractions here, times 5 times 12 cubed minus 12 to the 4th divided by 4. And I end up getting that. Okay, and so there's my answer. Work equals 3,763,200 pi. What would your units be? Don't forget this. Units are imperatively important. This is the metric system, so that would be joules. And then the last thing I did to this thing is go back and just integrate this guy, 9800, leave the pi off, math number 9. This would be from 0 to 12 of parentheses x divided by 3 squared times 15 minus x, close parentheses, dx. And just to make sure I got the same answer, so I didn't screw it up. Does that make sense? The other problem that was not on this exam that you should be studying is spring problem. So I thought we would do this one to remind you of the famous formulas you need to know for springs. For springs, there are 2 formulas. You need to know Hooke's law for springs. Force is equal to kx, and you need to know work is the integral of force, which is the integral of kx dx from A to B. But remember, you've got to zero out the natural length on this stuff. The natural length is 0. So if they tell you the natural length is 12, that you're going to take that 12 mark and subtract it from all the other units to get it down to 0. So let's take a look at this problem. All right. A force of 40 newtons is required to hold a spring that has been stretched from its natural position of 10 centimeters, so the natural position is 10 centimeters, to a length of 15 centimeters. So here's 15 centimeters. And it took a force of 40 newtons to be able to do this. The first thing to do on any spring problem is you got to find K. You got to find K. There's 2 ways to find K. They can either tell you force, and then you can solve for K, or they can tell you work, and you have to integrate kx dx with bounds, and then you can plug in top, plug in bottom, and solve for K that way. There's type 1 and type 2. There's only 2 ways to do spring problems. They give you either force or they give you work. So, this one they gave me force. And so, here's the thing. First thing I'm going to do is sit there and solve for K. But this was your natural length. You've got to zero it out. So 10 centimeters is actually 0 centimeters. That makes 15 centimeters how much? 5 centimeters. However, you've got bad units. When you're working in the metric system, you want to have a Newton meter joule for an answer. So the lengths must be in meters. If you're working in the English standard system, you want everything in feet. So you may have to convert. This one I got centimeters. But 0 centimeters is the same thing as 0 meters. But what is 5 centimeters in terms of meters? Centi means you divide by 100. That's 0.05 meters. So force is equal to kx. They told me a force of 40 is equal to k times the distance that you actually traveled was 0.05 meters. And so I'm going to divide. And so when I divide by 0.05 on both sides, I get 40 divided by 0.05 is 800. K equals 800. That's always the first thing you got to do to a spring problem unless they give it to you. The second thing is this. You're going to use that K to actually figure out the problem here. How much work is done in stretching a spring from 15 centimeters to 18 centimeters? So we're trying to stretch it out over here to 18 centimeters, and we want to figure out the work here, so there's my question mark. But remember, your natural length had to be 0 out. So if 10 centimeters is your natural length, that's got to be 0 out. That makes 18 centimeters equal to 8 centimeters. But 8 centimeters is 0.08 of a meter. You have to make it in terms of meters divided by 100 because it's centi. So work is equal to the integral from a to b of kx dx. So work is the integral from 15, which is 0.05, to 18, which is 0.08 meters, 0.05 meters to 0.08 meters, of k, which was 800 x dx. Again, if it's on the free response part of the question, you can show your integral. This will be 800 x squared over 2 evaluated from 0.05 to 0.08. So work would be equal to 400 times 0.08 squared minus 400 times 0.05 squared. And so I get work is equal to 400 times 0.08 squared minus 0.05 squared times 400. And double check me, but I got 1.56 what? Foot-pounds or joules? Joules. This was the metric system. I converted to meters, so that would be joules. Don't forget to go back and practice. There's two ways. The other way they could have done this problem is they would have given you work to solve for K. Does that make sense? The last thing I wanted to discuss and see if I can do this would be look over the multiple choice of my test on chapter 4. All right, so this is pretty much for my students, but to let you guys know, if you want to pay attention, that's fine. But a lot of students have a question of how I'm going to be doing grades this semester and stuff. I have linked your attendance to the ability to replace your lowest test grade with the final exam grade. And I haven't really decided what my cutoff is. I was thinking about if you have 2 or fewer absences, you get to drop your lowest, or replace your lowest test grade to final exam. But I may make that 3. But here's also the deal. If you've been showing up to those Friday review sessions, you can count that if you missed a little more of the days than you needed to. You can add those days into count away from the number of days that you missed. So if you missed a particular day, but you went to the review session, so you have to hit up Griff from the Section 4 class or Carly from the Section 5 class to figure out how many days you've missed and stuff. But I will be allowing the final exam to replace your lowest test grades for all those that qualify. Yes, sir. Oh, sorry. All right. So, but I'm disappointed in the performance on this last test. The last test class average was a 70, which was pretty pathetic compared to all the other tests I had. So I brought, and I wanted to focus on the multiple choice because the multiple choice part is what a lot of people died on. So, but I want to remind you of 2 things. Sequence and series, but I know they're also going to put on the final exam a problem about alternating series and estimating an alternating series. There's the alternating series estimation theorem, which means if you cut it off to 5 terms, where does your error occur at, the maximum amount of error occur at? The 6th term, the next term up. If you do 5 terms, it's always that m+1 term. The next term up is where your error. Whether it's a standard alternating series or an alternating power series. Listen to my words. An alternating power series. It's still alternating, so if it's alternating and they want you to cut it off at 5 terms, x to the 5th or whatever, the next term up will be where the maximum error occurs at. Does that make sense? For some value of x. So, let's take a look at this thing and see if I can do this in 15 minutes or less. Because it was embarrassing that you should have taken about 15 or 20 minutes on this thing, but let's take a look. Here was and I'm just going to focus on the multiple choice part. Sequences. All you had to do was take a limit. But pay attention, degree of the top and degree of the bottom. On this one, degree of the top and degree of the bottom is 2. So what is the limit as x approaches infinity of this problem? Watch your signs. It's the ratio of leading coefficients. It's 1 over, sign goes with it, -1/3. People weren't paying attention and put 1/3 down on this thing. Look at this guy here. This one killed a lot of students. Take your limit as n approaches infinity. This is when I'm forcing you, when you plug it in, you get n, natural log of infinity is infinity, so you've got to do L'Hopital's rule. This will be the limit as n approaches infinity of 1 over, derivative of 1 over n, natural log of n is 1 over n, but you got to flip and multiply to clean it up. Clean it up first. That becomes n. You get infinity. The answer was E. This one here. Again, this one was a L'Hopital rule twice problem. You plug in infinity, you get infinity over infinity. So I L'Hopital rule it. This is the limit as n approaches infinity of 2n over derivative e to the n is e to the n. But you plug it in, you get infinity over infinity, so you got to L'Hopital rule it again. So this is the limit as n approaches infinity of 2 divided by derivative e to the n is e to the n. This is 2 over infinity, which makes the answer 0. The answer was A, convergent to 0. The next one is this. And a lot of people died on this one because they weren't thinking about the problem. When you plug in the cosine, infinity, what's the cosine of infinity? It's not infinity. Cosine of infinity bounces between two numbers. What two numbers? It just bounces somewhere between -1 and 1. It's oscillating. It's a cosine function over infinity squared. A number, I don't care what it is, over infinity squared, which is infinity in the denominator, makes the whole thing go to what? 0. The answer was converges to 0. This guy here, look at it. It's a series. 5 on, I've dealt with series problems. What kind of series is it? Geometric series. But this one starts at 1, so I want the formula n goes from 1 to infinity of a r to the n minus 1. So I've got n of these guys. I've got too many. How many too many do I have? 1 too many. So this is the sum as n goes from 1 to infinity of pull off one of the ninths, and you get 1/9 to the n minus 1, which makes a equal to 1/9 and r equal to 1/9. But the absolute value of r is 1/9, which is less than 1. So this thing converges to a over 1 minus r, which is 1/9 over 1 minus 1/9. And you'll notice even on this one, I don't need a calculator. This is 1/9 over 8/9. Invert and multiply, and that's going to give you 1/8. This thing converges to 1/8. Does that make sense? Invert and multiply fractions. This one screwed up a lot of people because of the way I worded it. Now, I want you guys to know, I stole this off an old final exam. So the people that are making old final exams are going to steal the same type of stuff here. Here is a geometric series. But what the question is this, not if the geometric series is doing anything. Look at the questions. Is it divergent, convergent but not absolute convergent, absolute convergent, convergent but not absolute to this thing, absolute convergent? They're talking about absolute convergence or conditional convergence. When you test for absolute convergence, the first thing you do is you take the absolute value of your series. And what happens to this -1 to the n mess when you take the absolute value of it? Goes away. And there, this is the geometric series that starts at 0. They're giving both of them to you. And this would be 3/7 to the n when you clean it up. Which means this is the form of a r to the n when n goes from 0 to infinity here. A would be equal to 1 because there's understood to be multiplied times 1. And your r is equal to 3/7. Absolute value of 3/7 is 3/7, which is less than 1. So this thing does converge to, and it's going to be absolutely convergent to, a over 1 minus r, which is 1 over 1 minus 3/7. This is 1 over 1 minus 3/7 is 4/7, which makes it 7/4. It's absolutely convergent to 7/4, which makes the answer E. Does that make sense? This guy here, this is a classic, and I know they're going to give you one of these kind of problems on the test. This is a geometric series where they wrote it out. And when they write out a geometric series, you know it's a geometric series because you've got to figure out, what am I multiplying by this guy to get to this guy? What am I multiplying by this guy to get to this guy? What's my r value? 1/4. The a value is the number that you always start with, which is what? 5. When they write out a geometric series, this is your dude. Your a is the first guy, and the r is the number that you multiply one term by to get to the next term. So this thing, absolute value of r, which is 1/4 or less than 1. So once again, a geometric series which converges to a over 1 minus r, which converges to 5 over 1 minus a fourth, 5 over 3/4, which is, when you invert and multiply, what is that going to be equal to? 24ths? No, 23rds. Thank you. Better math. 23rds, which is B. This guy here. Now, on this particular problem, you got the sum as n goes from 0 to infinity of n cubed plus 2n minus 5 over n squared plus 3 times n to cube. There's lots of different ways of doing this particular problem here. Okay? But the question is this. All right? Well, and the question is this one. When I see the degree of the top is equal to the degree of the bottom, okay? Degree of the top equals degree of the bottom. That means when I take the limit as n approaches infinity of n cubed plus 2n minus 5 over n squared plus 3n cubed, I'm going to get what? 1/3? But now I'm summing it up. When you sum up 1/3, what's 1/3 plus 1/3 plus 1/3 an infinite number of times? Infinity. This is called the divergence test. So this thing is going to be diverging, so it's got to be one of the first three, but the obvious one would be diverging by the divergence test. Okay? Does that make sense? That was the one that I was going after and stuff, because integrating this thing is going to be awfully cumbersome in terms of being able to get these guys and fattening out and all the things you can do, but this one is the most direct answer was divergence by the divergence test, because the degree of the top is equal to the degree of the bottom. This one here, they love to give you these kind of problems on the test, and that is this: which of the following infinite series converges? First off, notice this one. We talked about this 14,000 times in class. Factorial's on top. What's that sucker going to do? Diverge. Factorial on bottom is going to converge. Factorial on top is going to diverge. This thing is divergent. This is the summing of 1. I don't care what this is. You got 1 plus 1 plus 1 plus 1 an infinite number of times minus something or other. I don't care. This is automatically going to diverge. This one killed me. A lot of folks picked on this one, but that's shameful. This is a p series, but what's p equal to? 1/2. And because the p series, p is less than 1/2, that means this thing's going to diverge. This thing is going to be plus or minus n squared. I mean, if you actually add this up and you're going off to infinity, you know, add 5, subtract 6, plus 7, as you square these numbers up and stuff, no. But this one, cosine squared, this thing's going to diverge, by the way. Cosine squared can be bounded by 1 over n cubed. I'm doing the direct comparison test. This is 1 over n cubed. This is a p series. P equals 3, which means it converges. This guy is less, so that by the direct comparison test, this thing converges. There's only one of these guys that converges. This guy right here is 1 over n squared. And they want you to use the direct comparison test, which means I need to compare something or other. I can only compare to things that look like 1 over n squared. Well, there's this guy, but here's your problem. Look at the word. That's the word diverges. If this thing converges, anything you've got to compare to must also do what? Converge. This is divergent. The word messed it up. That's the harmonic series. That thing doesn't even converge. That diverges. That's shameful. The factorial's on top, so guess what this guy's going to do? Diverge. This one's wrong. This one is the sine of n cubed, but with the sine, that's your alternating, because you got plus or minus, plus or minus. It's not squared. So sine bounces between, and somewhere between, -1 and 1, because it goes below and above. It's not always positive. When you do a comparison test, you can compare to only things that are positive. So the only answer is you compare it to this guy, because the n squared matches up, but the converges word matches up as well. Number 11 here. This guy is squared. So what test would I do? First off, what is this thing going to do? Personally, I would do a direct comparison test, because cosine squared is actually bounded by 1 over n squared. And you got that shifting fact, but that's okay with the shifting thing here. And I think this is actually should have been equal to 1. I think it's from my typo. But the fact is, this is a comparison test type thing here. So when you're comparing it to this guy converges, this guy converges. So the answer for this thing is it converges by the direct comparison test. So it won't converge. So the thing's not going to diverge. So forget that. So you're either going to do is you're going to do alternating series test, but cosine squared doesn't alternate. Would you ever use the ratio test on this thing? No, only powers of n or factorials. So no on this one. It's not alternating, so get rid of this. And this is what I was trying to show you. The only way you could have done it was compare it to the direct comparison test. This one killed a lot of people too because they forgot about the power series representation stuff. I'm trying to turn this thing into a over 1 minus r. So the first thing I got to do to my function here, so I can write it as the sum as n goes from 0 to infinity of a r to the n. So the first thing I'm going to do here is this. I'm going to take 2 over 3 plus x and multiply the bottom by a third and the top by a third. And when I distribute, I get 2/3 over 1 plus x over 3. So now my form matches up, but now I need to have a minus here. So this is 2/3 over 1 minus negative x over 3. So a equals 2/3 and r equals negative x over 3. So when I plug it into my formula, the sum as n goes from 0 to infinity of a, which is 2/3 times r, which is negative x over 3 to the n. Now I go start looking at this guy here. Because that negative is inside, I can factor them out. So this is the sum as n goes from 0 to infinity of 2/3 times negative 1 to the n times x over 3 to the n, which is, which one of these answers? N is 0, 2/3, x to the n, it's negative 1 to the n. The answer was A on this one. Okay? And it started at 0. I tried to mess you up with this starting at 1 thing. I'm using my power series starting at 0. So all these guys that start at 1 are not going to be my answers because when you do your power series representation to the geometric n, the sum starts at 0. They're trying to mess you up with that. Stole that one off an old final exam. This is a classic problem right here. The Taylor series centered at 0. You know I stole this one off the final exam because I would have told you it was a Maclaurin series. But there it is. We want a Maclaurin series for this guy. And you had to actually use the summation here. So this one is f of x equals e to the 2x. But what I have memorized is this. If g of x, which is if e to the x, is the sum as n goes from 0 to infinity of x to the n over n factorial. This is one of the series I demanded that you guys have memorized because I know it's going to be on the final exam. You know I'm going to put it on the test. This is your classic Maclaurin series for e to the x. But I want it for e to the 2x, which means I'm going to replace x with 2x. So this turns into the sum as n goes from 0 to infinity of 2x to the n over n factorial. And here's the sad thing. People got it down to this, and then they couldn't clean it up. What is 2x quantity to the n if you're going to clean it up? Sum as n goes to 0 to infinity. You're going to clean this up. This will be 2 to the n times x to the n over n factorial. So which one of these guys is my answer? N starts at 0. Pay attention to that. They like to mess that up with you. I believe the answer is D. Does that make sense? This guy here, find the interval and radius of convergence on this guy. Well, the first thing I'm going to do is find the interval and radius of convergence. What form do I use? Ratio test. So I'm going to take the limit as n approaches infinity of n plus 1 squared times x to the n plus 1 over 10 to the n plus 1 divided by n squared times x to the n over 10 to the n. When I invert and multiply, I'm going to get the limit as n approaches infinity of absolute value of n plus 1 squared, x to the n plus 1, over 10 to the n plus 1. 10 to the n's on top, x to the n's on top, n squared. And here, these guys cancel out, you're left with x on top. These guys cancel out, and you're left with 10 on the bottom because you had more 10's on the bottom, you had more x's on top there. But now you want to take the limit as n approaches infinity of this guy. You could clean this up to become n plus 1 over n quantity squared when you take your limit. Go after the n's on the inside, that's 1 squared, which is 1. That thing goes to 1. So I get the absolute value of 10 over x, it's got to be less than 1, which means, what a surprise, -1 is less than x over 10, which is less than 1, which is -10 is less than x, which is less than 10. This is almost my interval of convergence, but you got to test the endpoints. When I test my endpoints, watch this. When I plug in x equals -10, I'm going to get the sum as n goes from 0 to infinity of n squared on top times -10 to the n over 10 to the n. This is the sum as n goes from 0 to infinity of n squared times -1 to the n times 10 to the n over 10 to the n, and the 10 to the n's cancel. But this makes it the sum as n goes from 0 to infinity of -1 to the n times n squared. I'm going to use the alternating series test. But you notice right off the bat, when I start, the bn part is n squared. When I plug in n equals 0, n equals 1, n equals 2, I get 0, 1, 4. The terms are not going down, they're going up. And by the way, the limit as n approaches infinity of n squared is infinity. This thing fails all around. You do not want this -10 in your interval of convergence. If I do x equals 10, you get the sum as n goes from 0 to infinity of n squared times 10 to the n over 10 to the n. They cancel. You get the same series without it being alternating. N squared, and by the divergence test, n squared's on top. You take the limit as n approaches infinity, this thing's going to blow up big time. So it's going to diverge. So you don't want this guy, so the answer was A. You don't need the endpoints on either one. Does that make sense? Okay? Don't forget this question.
Is there a way that any example you did go to infinity, negative infinity, not infinity? Is there an example of that? What happens?
I'm sorry, what was that now?
Where on the last question,
Yeah.
like you go up to infinity, like the balance is negative infinity to infinity.
The bounds would be negative infinity to infinity?
No, would there be an example like that? Is there a problem like that?
Can your radius of convergence be infinity?
Yeah, sure. Your radius convergence can be infinity. You can have an infinity to infinity answer. Let me give you an example. X to the n over n factorial. When the factorial is on the bottom, the sucker is going to, quote, always converge. We did that problem in class. When the factorial is on the bottom, the series is going to always converge. I don't care what x you plug into it. Negative infinity to infinity. There's a classic example. Where's the classic example of a radius equal to 0 or a single point of convergence? The sum as n goes from 1 to infinity of n factorial on top times x minus 5 over n squared or whatever. Well, the fact is, with the factorial on top, that thing's going to almost always diverge. With the x minus 5, you can only plug in 5 to get zeros that will be able to add up. Everything else will diverge. So that we have a single point of convergence. So remember that factorial games I played with you guys. All right. With this particular problem here, again, I think a lot of people died on the ability to take derivative of it, but this is the problem that you have to know, and remember this, it's going to be on your exam. What is the formula for Taylor series? F of x is equal to f of a plus f prime of a over 1 factorial times x minus a plus f double prime of a over 2 factorial times x minus a squared plus dot, dot, dot. Okay? My function here is this. F of x equals cosine of x. I need to take its derivative, and this is what people died on. What's derivative of cosine of x? Derivative, not integral, derivative of cosine of x. Negative sine of x. What is the second derivative? What's the derivative of negative sine of x? Negative cosine of x. What is my third derivative? What's the derivative of negative cosine of x? Back to sine of x. Okay? And then I'm going to plug in my points, and my point is pi halves. And derivative of pi halves. You notice I didn't write down many terms because I don't need to be able to recognize the series in this thing. That's the second derivative. This is your third derivative of pi halves. And maybe the other thing was, well, you had your calculator, so you can't argue this. What's the cosine of pi halves? 0. You can put it on a calculator if you don't memorize it. But cosine of pi halves is 0. Sine of pi halves is 1 with a negative. That'll be -1. The second derivative cosine of pi halves is 0. And the sine of pi halves is 1. So when I plug it into this thing, the cosine of x is equal to 0 plus -1 over 1 factorial times x minus pi halves plus 0 over 2 factorial times x minus pi halves squared plus 1 over 3 factorial times x minus pi halves cubed. So which one of these guys is it? Well, these terms knock off. So you've got to have that negative 1 over 1 factorial times x minus pi halves. And which one is that one? The answer is which one? Got to be D. Oh, here's one, just to answer your questions just a few seconds ago. Look at number 16. What is the radius of convergence of this power series? Here's the beauty of it. This is what I want you guys to use. I would use the ratio test to prove this thing, but you shouldn't have to. You should have been able to look at this thing and tell what the answer is. Where is the factorial? On the bottom, which means I don't care what kind of power series they give you. When the factorial is on the bottom, this thing is going to do what? Converge. Always. So it always converges, which means my interval of convergence is negative infinity to infinity, forces my radius of convergence to be infinity. All you got to do is look at it. A lot of these problems are 10-second problems if you memorize the formulas. But again, if you wanted to show it, use the ratio test. But the problem is when you use a ratio test, you'll have an x over like an n plus 1. And when you take the limit as n approaches infinity, you get x over infinity, which goes to 0, which is always less than 1. Here's one of those alternating series estimation theorems. Here's the deal. Find an estimate for the error using the first 4 terms of this alternating series. First 4 terms. The alternating series estimation theorem says my error, which is the Rn, which by definition is the true sum minus the partial sum, is less than or equal to Bm plus 1. In this problem, n was equal to what? 4. So this would be B4 plus 1, which is B5. Your Bn in this problem is 1 over 5n, the part without the alternation. So this will be 1 over 5 times 5, which is 1 over 25, which is 0.04. The answer was C. Does that make sense? Again, don't forget this. They're going to hit you. And I don't care if it's a regular series, alternating series, or a power alternating series. If they tell you to stop at 4 terms or 5 terms, your error is always the next term up. This problem here was a question on what could you use to figure out whether this thing converges or diverges. First off, would you ever use the ratio test on this thing? No. Why not? No powers of n, no factorials. No. So this is not it. Only use ratio test on powers of n or factorials. So it's either the divergence test or the integral test. Could you integrate this thing? You should. That's kind of part of the class here. Yes, I can integrate it. So I'm going to tell you it diverges. The answer is divergent. But could you use the integral test on this? Yes, I could. So there's one answer. Could you have used the divergence test? What is the divergence test? Take your limit as n approaches infinity of the sequence part. Natural log of n squared over n. And if you get a number that's not 0 and not infinity, excuse me. When you take the limit as n approaches and you don't get 0, you get anything else, the series is going to diverge. It's called the divergence test. So, but when I plug it in, I get infinity over infinity, so I got to L'Hopital rule it. L'Hopital rule on this thing, this will be the limit as n approaches infinity of, the derivative of this thing is chain rule. 2 times the natural log of n to the first power times 1 over n, divided by 1. Clean them up. This is the limit as n approaches infinity of 2 times the natural log of n over n divided by 1. So guess what? I made you do a L'Hopital rule again because it's infinity over infinity. When you do L'Hopital rule again, you're going to get the limit as n approaches infinity of 2 times 1 over n divided by 1. When you plug in infinity, you get 2 over infinity, which equals 0. What does the divergence test say when your limit goes to 0? It doesn't say squat. It says the divergence test says if I take my limit as n approaches infinity and I don't get 0, it'll diverge, right? So I could not have used this guy. The only answer was B. This one, I thought everybody would get this one right. I was wrong. All right, so what kind of series is this guy? I got 3 over n to a power. P series. Your power for P series is, in this case, is 2x plus 5. When does a P series converge? When it's strictly greater than 1. Solve for x and don't hurt yourself. Subtract 5, okay. I get 2x is greater than 1 minus 5 is negative 4. Divided by 2, I get x is greater than negative 2. That's pretty much D. But you'll be amazed how many different answers I got for this dude. And the last one, I really tried to make it simple, but it was one of those questions that, did you memorize the formula or not? What is the power series for the tangent inverse of x? If you knew that, you won the game. If you didn't, well, there's always the guess and check method. So, tangent inverse would look like what? It was the odd guys. It was x minus x cubed over 3 plus x to the 5 over 5, plus dot, dot, dot. Remember that guy? But you needed to remember also the series. This is the sum as n goes from 0 to infinity of x to the 2m plus 1 over 2m plus 1. That is your power series. That was the formula for it. So if you wanted the power series for the tangent inverse of x over x, all I do is replace this guy with the sum as n goes from 0 to infinity of x to the 2m plus 1 over 2m plus 1 divided by x. But you can pull this guy on the inside, right? So this is the sum as n goes from 0 to infinity of x to the 2m plus 1 over 2m plus 1 times 1 over x when I put it on the inside. And x to the 2m plus 1 divided by x, you subtract, gives you the sum as n goes from 0 to infinity of x to the 2n over 2m plus 1. Because that divided by that, basically I subtract exponents, which made it... yeah, this one. Answer was alternating. I lost the alternating part, didn't I? Sorry, negative 1 to the n. Sorry, I was trying to do this thing at 90 miles an hour. Negative 1 to the n, negative 1 to the n, negative 1 to the n. Yeah, the answer was A. Because remember, it's alternating. Plus, minus is negative 1 to the n. So, did this make sense? Again, I want to do it very quickly because I've already kept you guys here, as I promised, 2.5 hours. It was actually 3.5 hours, but I try to give you a very comprehensive review. Don't let this be the only exam you guys study. There are more exams out there. Practice. Your life depends on it. See you guys later. And don't forget, for my class, when's your exam? Tomorrow. You got to be here at 2:30. At what time? And this classroom, Fretwell 100. See you guys then.